Testing audio. Right. Okay, we'll start. All right, we'll start. Right. Good evening. We'll start. Online students, what about the audio and the video? Okay. Listen. Right, listen. Right. So now I hope, especially for the students who are living outside this town, Orana, you are now fine. I mean, most of the things are now getting better, right? Not the initial previous state we had, right? So after disaster, it takes some time to recover, right? And to come to the lifestyle you have been doing and to the level that you are living, so that it will take some time. But now essentials are getting better, right? Like water, electricity, right? Internet. So likewise, those are essentials now, no? Right? Now that state is kind of getting better, but there are small villages and areas where they don't have water and electricity, right? Especially the areas that they have gone gone through severe landslides, right? So unlike floods, now if there is flooded, once the flood is gone, then you have to clean the stuff and everything that's there. But the damage is minimum compared to a landslide. Damage to infrastructure is minimum. Most probably, if there are no any major damages to the electricity lines, the power will be back. But when it comes to the areas where the landslide has occurred, infrastructure is damaged. Therefore, it should be repaired. And there are some villages still without having any road access, even by motorbikes, right? So things are getting better. So that's why I had to call off the class for last week, right? And I actually didn't do any class in the last week from last Friday to today, right? Yeah. Okay. Now, still, if there's anyone who has any concerns, anything, any major concerns like water issues, electricity issues, or something like that, so kindly let me know. I mean, just to get aware, because now if you don't have electricity, even if you are joining online, there are issues arising. No, that's why. So that was a disaster anyway, and whether you have gone through it or not, so that was a disaster where a majority, or let's say a significant amount of population of Sri Lanka was affected, right? And in the last class also, what I was saying was, the awareness made to the public is not that sufficient from the government and the meteorological department and whatever the authorized bodies, right? So if you can remember, in the last paper class we had, I told you that a storm is coming up, right? So if you can't remember, just check the recording of the last paper class we had, not the last week, the class before the last week, right? I just told you that a storm is coming on Thursday and these are the websites I'm checking, right? Video.com and කිව්වනේ. ඉතින් ඒක තමයි. ඉතින් අර ක්ලාස් එකේ ළමයින්ටත් මම කිව්වා I'm just a general public person, a person who is representing the general public of the country, no. මට නැතුව meteorological department එකත් එක්ක contact එක එහෙම එකක් නෙමෙයිනේ. And I'm not into that field, right? But yet I knew that it's coming. But the thing was, there was no awareness made by the particular department on that regard until Wednesday night actually. So by the Wednesday night, the rain has already started and the storm was there at the Wednesday night. It was forecasted that the storm is coming in Thursday morning, but it came in Wednesday night, right? So that was the thing. That's why the damages were kind of uncontrollable, right? They were severe damages compared to like other flood cases and other disasters we had, right? Not up to the level of tsunami, right? Were you born by the time of tsunami? No. 2004? No. You are 2008, 7? Huh? 7 or 8? 7. Right. So the last incident, I mean, as a disaster, the last incident I also can remember in my childhood is the tsunami incident. Right? The number of death count was way higher than this one. But the thing is, since that was a tsunami incident, right? That was just for 2-3 hours, and then the everything was, I mean, the vulnerability is gone off. But here the thing is, now since the soil layers and all that are have become unstable, right? Still there is the risk of having landslides. තාම තියෙනවා. ඒක නැති වෙන්නේ නැහැ. දැන් monsoon season එක පටන් ගත්තාම ඒක තව කල් යනවා. Now the monsoon is started already. Right? ඒක කොහොමද තියෙන එකනේ. monsoon season එකේ තියෙන rains කොහොමද වෙනවා? බදුල්ල, කැන්ඩි ඔය areas වලට කොහොමද rain එක වැඩි? So therefore that risk is still there. Right? So even though there is no rain, no visible rain, right? So due to the unstable soil layers that were already unstable due to the rainfall that we had before, there is a chance of occurring landslides, right? Video එක ළඟදී share වුණා දැක්කද? කිසිම වැස්සක් නැහැ. හොඳට පාලා තියෙන දවසක buildings තුනක් කඩාගෙන වැටෙනවා මේ ගන්නෝරුවේ. දැක්ක නේද? දැක්ක නැහැ. මේ එහෙම තමයි. ඒතර අර earth flow එකේ තියෙන මේ ground level එකේ තියෙන water flow එකත් එක්ක තමයි ඉතින් මේ දේවල් වෙන්නේ. Right? So that's the thing. So therefore I also had to call off all classes in the last week, and today only I'm starting the classes again. And actually I dedicated few days from the last week for the donations and everything. If you are in my social media and WhatsApp social media or any other social media, Instagram, anywhere, you might have seen it, right? So what I need to say is, since there were no correct awareness or proper awareness given, the damages are higher, and when it comes to death effects also, it was higher, right? But there are some set of people who are like, even if they are informed, they are like kind of stubborn to, they are reluctant to go out. Such cases are also there. But the majority was not properly got the message. That was the thing, right? So therefore the incidents were severe, and the death count is not the count that it's saying nowadays. Now it's around 500 or something, no? 480 or what's the count? 600, right? Now, if it says it's 600, it should be more than 1200 now. For sure. What's the misplaced count? That misplaced count is for sure it's dead. So, ඒක ඇඩ් කරලා බලන්න එතනම 1000 විතර එනවාද? ඊට පස්සේ ඔය රෙකෝඩ්ස් වල නැති කට්ටිය ඕක ඩබල් වෙනවා කොහොමද? ඒ නිසා ඔය official death count එක නෙමෙයි the actual count. Right? If there is 600, say 500 people are missing, then that's altogether 1100. එතනම. There are people who are not recorded in those lists. Right? ඒ කට්ටියත් ඇඩ් වුණා. අපි හිතනවට වඩා මෙතන severe. Right? Now, as a district, Kalutara district was not that affected, and southern province was not that affected by this disaster. For other areas in the country, more or less they got the rainfall, and there are cases, right? So even in Colombo, right, due to the storm, no any flood case. I mean, for the river basins of Kallan River, floods are there, but for all other areas in Colombo, in Gold Road even, Gold Road, Malath Road, those ones, there were trees falling cases and everything due to the storm. So as a district, Kalutara is kind of better because this river, I mean, Kalu, this river doesn't get any, I mean, that much of rain compared to Kalani and Mahavali. That was the thing, right? For the ones who are living around the basins of Mahavali River and Kalani River, they got the highest impact, right? Comparatively, මෙහෙ එකට අඩුයි. හරි. තෑර නම්බර් පානේ කොහොමත් යට වෙනවනේ. ඒක ස්ටෝම් එක ආවත් නැතත් වැස්සොත් ඒක යට වෙනවනේ. ඒක කොහොමත් වෙනවනේ. ස්ටෝම් එක කියලා අර ලොකු එකක්කුත් නැහැ. Due to the storm, the rainfall we got was more than 3 times of the average rainfall we are getting in the country. That was the thing, right? So anyway, now I hope you are doing a little bit fine, and now things are getting better. Things are getting better, and you might have seen that I have shared a flyer on that regard, as if there is anyone who has affected from the condition, right? So from our side, what we can do is we can take you into the class freely, completely free, absolutely free. So that I shared in the group and the channel, right? So if there's anyone who needs that support, right? So that is what I can give from my side. Doesn't matter whether he or she is facing the exam in 26 or 27, right? So until the date that they are going to sit for the exam, the class will be entirely free, right? So that I have already given. I mean, that opportunity is already given. So maybe your friends or someone who is in need of that, you can share the details and ask them to join. There's no any conditions or nothing like that. They can just freely join if they have affected, right? Okay. And especially in these days, if you have your friends who has got affected, try to help them as much as possible, because now sometimes their notes are misplaced, or sometimes note have got wet and tudes are misplaced. They have gone with the flood, right? Such cases are there, right? Especially in the other areas around Badul, Kandy, Gampola, Matale, right? And some areas in dry zone, right? So therefore, if you have any possible way of giving them a support, don't think twice. Just give your support to the fullest and help them out, right? ඉල්ලන ඕන දෙයක් දෙන්න. ආයි දෙපාරක් හිතන්න එපා එහෙම ඕන ඉල්ලන්න කලින් දෙන්න. ඉල්ලනකම් බලා ඉන්න ඕන නෑ. Just ask them whether they are doing okay, if their notes are missing, right? Missing now, ඔයාලට දෙන්න පුළුවන් support එක දෙන්න. Right? Help everyone, especially the A-level students who have got affected. to come out from that thing that they have faced, right? So it will get recovered in the coming weeks. So until then, they need our support. That's why, right? They need our support. පුළුවන් ඕන විදිහකට support කරන්න. Maybe just by a word, right? Or maybe a note, right? Not anything financial sometimes, right? Something that you can do, right? Something that you can do. So please provide that support for them until they are coming to their normal lifestyles again, right? Okay, and now you also have contributed. I have to say this thing in the class. You also have contributed for the donations that I have done, because I went for 2 villages on 2 days, and now what I have donated is, it's my money I have, which means those are the things that I'm getting from your fees, right? So therefore you have also contributed there, right? So that is something you can be proud of yourself, right? So even though you were not there physically, your contribution was there, right? So that's valid for any one of you. Your contribution was there, right? මං donate කරා කියන්නේ ඉතින් ඒ donation එක ඇතුලේ තියෙන්නේ class fees වලින් ආපු සල්ලිනේ. එතකොට ඕගොල්ලෝ එක donate කරලා ඉවරයි, right? ඒ නිසා තව මොනවා හරි කරන්න පුළුවන් දේවල් තියෙනවා නම් කරන්න. ඕගොල්ලෝ ඇත්තටම එතකොට donate කරලා තියෙන්නේ. So be happy about yourself and be proud of yourself. ඒතර මම කරා කියන්නේ ඉතින් ඕගොල්ලෝ කරා කියන එකම තමයි, right? ඒතර තව කරන්න පුළුවන් නම් කරන්න. That is better. But now you also have contributed, right? Already. Okay. Right. So we will start. Now, since I had to call off the class last day, I gave you a homework paper, right? And I'll be discussing that homework paper today, right? That is in the group. That is in the group. And if you have got the hard copy, you can refer this. If not, you can get the hard copies from here, the physical ones, right? If you have already got the hard copy of that paper, you can refer it. So if not, you can get it from here, right? And one more announcement before starting the class. The other thing is, now I have been telling this thing in the previous weeks. I have been telling these things in the previous weeks that we are going to start writing papers and you are going to get the graded papers this month onwards. No? So since we had a holiday last day, right, it was shifted to this week. So therefore, listen, this is important. Now this week onwards, our ongoing class plan is going to change a bit, right? So which means even if you are writing the paper physically or as an online, you can write the paper on a separate time, right? So if there is the Leesa Institute here, right, I will inform you what are the available dates here, right? Say you are having 3 or 4 available dates to write papers, or if the institute is open, I have asked them to give you the paper, because I'll be handing the papers to the office tonight, right? Which means tomorrow onwards you can get the paper from the office. And now let's say for this week you have a MCQ, so you know the allocated time is 2 hours now. Then get a sort of 2 hours and come here physically and write the paper. And if you are writing it in Machma, right? For Machma also I'll be handing the papers. So what you can do is you can go there and ask the paper from them. I have already instructed them as well. You can get the paper and be honest to yourself during those 2 hours, because I will not be there by the time that you are writing the paper, right? So therefore be honest to yourself and write the paper, get 2 hours and write the paper, and again hand it over to the office and you can leave, right? And by Friday, I'll be collecting all papers, right? So by Friday. So therefore, before Friday, now from Monday to Friday, you can use any time to write papers. That's the best case. Then by Friday, I'll be collecting it from the institutes and it will be graded during the weekend. And my plan is to give the graded paper by Monday again when you are coming to the next class. Right? And on that particular day, what we are discussing is that paper that you have written during that week. Right? Then you have got the graded paper already and you are listening to the discussion in the class. Right? So that is how it's going to go. Right? And if you are writing online, for online ones also, I'll be allocating you times from Monday to Friday, right? So you can go there, you can go to that particular week and go to the exam. Exam will be there as renamed with the paper number, right? Paper 5, something like that, right? So go there and once you click on that, your time will be open and write it for 2 hours and you can do the submission as a PDF to the same what do you call that, a button kind of a thing is there, so that button, right? Then by Friday I'll be downloading all the online submissions as well, right? And all online papers will also be marked, it will be graded, right? So therefore make sure that you are submitting the PDF. And anyway, if you are not submitting a PDF, you can't upload it there, right? So that's restricted anyway, so make sure that you are uploading the PDF. And for online students also, it's more or less the same as physical students. The thing is, you can download the paper from the LMS from the website as you do now, same thing. And you can try it in a particular slot and you can upload it there, right? So I'll be creating it with an uploading link with a submission, not a link actually, with a submission button. So do the submission as you are doing the other exams in theory classes, right? Same thing. Okay, so that is how it is going to go this week onwards, right? These are the dates that I have got from the institutes. Listen. These are the dates that I have got already from the institutes. For here, Leesa, if the institute is open, you can come on any day. That is totally fine, right? If the institute is open, then you can come here from Monday to Thursday. From Monday to Thursday, if you are coming to any other class on a particular day, also you can come a little bit early and try it, or after the class or before the class or something like that. Or else if you are nearby, or if you are say coming to another class in a different institute or somewhere, right? So you can come here to the institute physically from Monday to Thursday and ask the paper from the office, right? And get it, and they will allocate you a hall or a space to write it, right? So in that space, you can write the paper for 2 hours. If that's a second paper, it will be for 3 hours. So likewise, you know what the time now. And be honest to yourself, because I won't be here. That's the thing, right? Now, if you are writing here on Wednesdays, I'll be here. And if you are writing in Machma on Thursdays and Fridays, I'll be here. Otherwise, in other days, I won't be in the institute, no. Right? So therefore, be honest to yourself. Then only you can reflect, you can get an idea about your actual level. Right? Now, otherwise, say now you are writing this as an open book exam. Open book it was the say that you have got 80 marks, right? I know 80 marks get but your parents will be happy, and I don't know. Sometimes මට ඒක අහුන්නේ නැත්තම් මමත් බලයි මට සමහරට අහු වෙනවා. ඒ කියන්නේ මම දන්නවනේ ලෙවල් එක මොකක්ද කියලා. අහුන්නේ නැත්තම් ඊට පස්සේ දැන් එහෙම ඉන්නවා මම මාව පැත්තකින් තියන්නකො. your parents will be happy. ඊට පස්සේ දැන් එක්සෑම් එකට ගිහිල්ලා ඒ වගේ ලකුණක් ආවෙ නැතුණාට පස්සේ ඉවරයි. ඒ නිසා එහෙම කරලා වැඩක් නැහැ හොඳ. ඒ කියන්නේ එහෙම කරා කියලා ඔයාලට හම්බ වෙන දෙයක් නැහැ. වැඩක් නැහැ. ඒ ඔයාලට බෙනිෆිට් එකක් නැහැ. කාවත් රැට්ටුවා කියලා ඉතින් මේ බෙනිෆිට් එකක් හම්බ වෙන්නේ නැහැ. වැඩක් නැහැ නේද? ඔයාලට in return you will get nothing. right? in return you will get nothing. එහෙම තමයි හැටි. හරි? ඒ නිසා මේ කරන වැඩේ හරියට කරන්න. එච්චර ගන්න තියෙන්නේ. ඉන්නේ ලකුණු 30ද 35ද ඔයාට ඒක honestly ඔයාගත්තු මාක් එකක් නම් ඒක ගන්න improve වෙයි. හරිද? හැබැයි බොරුවට අරගෙන වැඩක් නැහැ. හරිනේ? so therefore be honest to yourself in your writing. ලීසා එකට මෙන්න මේ දවස්වල ඇවිල්ලා ලියන්න පුළුවන්. right? Monday to Thursday. එහෙම time එකක් කියලා fix time එකක් නැහැ. institute එක open ඕන time එකක් එන්න. schools පටන් ගත්තට පස්සේ නම් mornings වල Wednesday මම ඉන්නවා. ඒ next week නම් ඉන්නවා. next week නෙමෙයි this week නේ. this week නම් ඉන්නවා. Wednesdays වල මම ඉන්නවා. ඒ අරන්න අනිත් දවස් ඉන්නේ ඉතින් evenings වල මේ Monday. අද evenings වල ඉන්නවා. right? මං ඉන්න දෙයක් නැහැ. ඕගොල්ලෝ ඇවිල්ලා ලියන්න. හරි? දැන් මේ paper class එක පටන් ගන්න කලින් වුණත් කමක් නැහැ. ඒ කියන්නේ දැන් මම 6:30 start කරනවා නම් ඔයගොල්ලන්ට කලින් class එකක් නැත්තම් 4 වගේ වෙද්දි මෙතෙන්ට ඇවිල්ලා 4 to 6 paper එක ලියලා මේ class එකට ඉන්න පුළුවන්. That is something that is totally up to you, right? You can do it as you are comfortable with, right? That's totally fine. මෙන්න මේ dates වල ඇවිල්ලා ලියන්න පුළුවන්. And make sure that you are writing it before Friday because by Friday I will be collecting. නැත්නම් මට මාක් කරගන්න time එකක් නැහැ නේ. හරිද? මාක් කරගන්න time එකක් මතුනාට පස්සේ මට අනිත් දවසේ දෙන්න paper එකක් නැහැ. ඊට පස්සේ දෙන්න විදියක් නැහැ නේ. Right? So by Friday I will be collecting. Right? So in Machma also I will be collecting by Friday. Right? exam මේ දවස් 4ක් තියෙනවනේ. manage කරගන්න පුළුවන්. And if you didn't write the paper, which means by the next class, by the next Monday, you won't get the graded paper. ඉතින් ඒතකොට right ලියුවේ නැත්නම් ඉතින් මට දෙන්න paper එකක් නැහැ නේ. Right? And for Machma for you what you can do is the days that they have given are Monday and Tuesday for now, right? So if there are any differences, I'll let you know. For now, it's Mondays and Tuesdays, right? For Machma, process is same. You can get the paper and write it. They will put onto a hall, right? And you can write the paper during that time and hand it over to the office again and leave. Make sure that you are writing your name and index properly, yeah? Especially the name. ඊට පස්සේ වන්න බෑ ඉතින් මම hand writing වලින් වන්නේ. Right? And for online students it's same like this. For online ones also it's same like this, huh? For online ones also it's from Monday to Thursday it will be available, right? The submission link will be available, right? So this is how it's going to go. Hane? So take this advantage, huh? This is an advantage because when you are getting a graded paper, already වෙන මොනවා හරි subjects වල එහෙම classes වලට යනවා නම් දන්නවද? graded paper එකක් ඔයාලට හම්බ වෙනවා කියලා කියන්නේ ඒක ඇත්තට මමත් නෙමෙයි මාක් කරන්නේ. ඒතොර වෙනම outside කෙනෙක් මාක් කරන්නේ ඕගොල්ලන්ව දන්නේවත් නැති කෙනෙක්. හරිනේ? ඒතොර එහෙම කෙනෙක් මාක් වෙනවා කියන්නේ හරියටම ඕක නිකන් අර exam paper එක මාක් වෙනවා වගේම තමයි. දැන් මම බලද්දි මම දැන් නම ලියලා තියෙනවා මම දන්නවනේ දැන් අදීශ නම් අදීශගේ paper එක මේ කියලා මම දන්නවනේ. හරිද? ඒතොර ඇත්තටම බලන්න 25 batch එකේ කට්ටිය මේ සමහරට අඳුරන කට්ටිය ඉන්න පුළුවන්. හරිද? 25 batch එකේ අඳුරන කට්ටිය ඉන්න පුළුවන්. දන්නේ නැහැ කියන්නකො. හරිද? එහෙනම් අඳුරන කෙනෙක් හිටියොත් ඉතින් එහෙම වෙන්න පුළුවන්. So someone, a stranger will be marking it, right? For you, the person who is marking it is a stranger. හරි? ඒතර ඕක හරිම විදියට ඒතර මාක් වෙනවා හොඳේ. ඒ කියන්නේ අර එක්සෑම් එකේ බලන විදියට මාක් වෙනවා. වැරද්දක් තිබ්බොත් පැන්සලෙන් හදලා ලකුණු දෙනවා. එහෙම නෑ හොඳේ. ඒතර හරි විදියට මාක් කරනවා. So therefore you can get an idea about your exact level. හරි හරියටම ඔයාගේ level එකේ තියෙන reflect වෙනවා. Right? And then once you know your level only you can improve. Right? Level එක දන්නේ නැත්නම් ඉතින් improvements කරන්න බෑනේ. Right? So get that advantage and these are the times හරිනේ. Is it clear? Oh, any questions on this? මේක අපි last week තමයි start කරන්න හිටියේ, but the thing was the flood and the holiday you had. Last week නෙමෙයි, this week start කරන්න හිටියේ. මම last week තමයි කියන්න හිටියේ. නැත්නම් අද තියෙන්නේ අර මේකේ first week paper එකේ discussion එක. Right? Any questions? All good? Clear? Online? Any questions? Quickly. So if there are no questions, at least put a thumbs up. Or if you have any questions, quickly ask. Quickly. Clear? All right then. Okay. So be clear with your work, Inza. Because when someone else is checking your answers, your handwriting should be clearly visible, should be clear, right? And your x and multiplication should be clear. X එක මෙහෙම ලියලා multiplication එකත් මෙහෙම ලියනවා නම් ඉතින් හොයන්න බෑනේ. ඔක අනිත් පැත්ත if you are writing x like this and if you are writing the multiplication also like this හොයන්න බෑ, right? එහෙම ඒවා ලියන්න එපා. දැන් row එක ලියද්දි row එක නිකන් මෙහෙම e වගේ ලියනවා නම් හොයන්න බෑ, right? So be clear with your handwriting, right? In the coming months, I'll be actually my plan is to give you the writing papers as well, writing sheets, right? Writing sheets. January or February වගේ වෙද්දි ගොඩක් වෙලාවට හම්බ වෙයි. Until then you can use your own sheets and write, right? මගේ next plan එකේ මම papers දෙන්නම්. එතකොට ඒ paper එකේ මේ papers කියන්නේ අර exam එකේ හම්බ වෙනවා වගේ අර තියෙන්නේ. අන්න ඒකම දෙන්නම්. Now for this month you can use your own sheets, right? And especially when you are writing second papers, right? So make sure that you are tying up, collating all the sheets and tying it up. දැන් පොළ තැන් වල දාලා එහෙම යන්න එපා. ස්ටෙප්ලර් එකක් ඔයාගාව නැත්නම් ඔෆිස් එකෙන් ස්ටෙප්ලර් එකක් ඉල්ලගෙන ඒක ටයිකල් මේ ක්ලිප් කරලා යන්න. හරි? ඊට පස්සේ නැත්නම් දැන් පේපර් එක ගන්නකොට කෑල්ලක් එක පැත්තක කෑල්ලක් තව පැත්තක එහෙම ඊට පස්සේ නැති වෙලා මාක් කරන්නත් බෑ. එහෙම වෙනවනේ. right? Good. Right. Are you clear? Okay. Now as I told you before, today I'll be discussing that homework paper I gave last day, right? So I hope all of you have tried it, except the ones who have severely affected by the flood and rain. Adisha, try it. Huh? බොරු කියන්නේ දැක්කේ නෑ? දකින්න නම් නැති වෙන විදියක් නෑ. එහෙනම් බලන්න නැතුව ඒක. මම දැම්මේ කවද්ද? ගොඩක් ලාස්ට් ඒවා කවුරුහරි group එකෙන් අයින් කළාද නෑනේ? ඔය දැම්මේ නැද්ද ඔයාලා කරේ? ඇත්ත? one second. මම කවද්ද අතර පේපර් එක දාලාද? Wednesday. මේ කට්ටිය රියැක්ට් කළාද තියෙන්නේ? රියැක්ට් කරපු කට්ටිය කොහොමද පේපර් එක කරලා දෙන්නේ? Okay. Right. Let's start. Question 1. Okay, question 1. Which of the following have same units of? This is a homework paper and then download කරන්න බැරුව සමහරවිට අර WhatsApp එකේ එහෙම කේස් එකක් තියෙනවා. දන්නවනේ? තාම පුළුවන්ද? WhatsApp එකේ expiry period එකක් තියෙනවා. default එක නැති කරන්න බෑ. Telegram එකෙන් නම් පුළුවන් ඕන වෙලාවක ගන්න. Right. This is a homework paper and where the questions from waves and optics are not included in this paper. because this is a homework paper I gave. Since I had to stop the class, I mean, I had to give you a holiday. That's why I gave you that paper, and that was actually not specifically made for your class, right? ඔය මගේ කලින් තිබ්බ paper එකක් මම දුන්නා. මොකද affect වෙච්ච නැති කට්ටිය ඉන්නවනේ ඉතින් ඒගොල්ලන්ට වැඩ කරගන්න හින්දා. Right, first one. Which of the followings have same units of force into time? That's a very popular quantity. Force into time. What is it? As a single term, force into time is impulse, right? There are only two equations for impulse. Impulse equals either Ft or delta mv, right? Ft or delta mv. Then impulse is correct. Impulse is correct. Power wrong. Momentum is correct. Because change of momentum is a momentum. Momentum is correct. A and C. Only A and C. Answer 3. For first one, answer 3. For first one, answer 3. Right? Second one. Consider following statements made regarding zero error of a vernier caliper. Zero error depends on the measurement taken by the instrument. What do you say? Zero error depends on the measurement taken by the instrument. No. Zero error is given. If the zero error is, let's say, 0.02 millimeters, then in each and every reading you are taking, that 0.02 is included. Depend on that, that's a given value. If the zero error is known, then for whatever the reading that you are taking from the instrument, you can do the correction and get the correct reading, right? Instrument again, zero error, that is not with the reading, that is with the instrument, right? So first one, A, B and C. A, zero error depends on the measurement taken by the instrument. No. Zero error can be omitted by taking several readings for a measurement. What do you say? No. By taking several readings, zero errors cannot be omitted. Which errors can be omitted? Human errors, or you can say parallax errors. Instrument errors smooth කරන්න බෑ. Human errors නම් ඔන්න නැති කරනවා කියන අතර minimize කරන්න පුළුවන්. Human errors can be minimized if you are taking the average of multiple readings, right? So especially parallax errors. But zero errors cannot be omitted. Zero errors can be omitted wrong. The only possible way to correct a zero error is doing a correction, either positive or negative correction, right? Only way of doing this is by a correction only. See, zero error should be added or subtracted from reading accordingly to make corrections. It's correct. It's exactly correct. C is correct. So answer is only C. Only C. 3 again. For 2, 3 again. Only C. Third one. The relationship between angular acceleration alpha, angular displacement theta, and time is given by theta equals k alpha t squared. Dimensions of k is, see, dimensions. What's the equation? Theta equals k alpha t squared. Theta equals k alpha t squared. Right. So if you need to find dimensions of k, substitute all dimensions of other physical quantities. Theta, angular displacement. Angular displacement is an angle. What are the dimensions? Dimensionless. If dimensionless in a calculation, mention it as 1. Right? We need k. Alpha, angular acceleration. What are the dimensions? Angular acceleration. Huh? What are the dimensions of angular velocity? It's a very popular quantity. What are the dimensions of angular velocity? T minus 1. Right? 2028 right? Omega equals theta over t. Right? General equation of angular velocity. Omega equals theta over t. Theta is an angle. T is time. So this is 1 over t. So this is t minus 1. Dimensions of omega is t minus 1. Right? Alpha is delta omega over t. delta omega over t. So that is t minus 2. That is t minus 2. So dimensions of alpha is t minus 2. And time is t squared. These two cancels. See, it says k equals 1. 1 means dimension less 5. So 3, answer 5. Four. Four. Centripetal acceleration is f of an object travels in a uniform angular velocity omega. Uniform angular velocity, yeah? That is important. Uniform angular velocity. The correct variation between omega and f is graph plotting. Graph plotting, right? You have met more questions, right? In other papers also from graph plotting. ඒවත් මම explain කරලා තියෙනවා. ඉතින් මේකත් ඒ විදියමයි. What's the equation of centripetal acceleration? R omega squared, right? If there is mr omega squared, there is centripetal force, right? Acceleration is r omega squared. There are only two ways that we can write centripetal acceleration, right? So either as r omega squared or v squared dou r. Now omega is given, no? So therefore we will be choosing this equation, right? And centripetal acceleration is given as f now. It is given as f. So f equals r omega squared, right? F with omega is asked, right? F with omega. Omega is at y-axis. Then subject y. මේ last එකෙත් මම මේක discuss කරා මොනවාරි structured වගේ එක. මේක කියන්නේ මේ graph plotting ගැන මම මතක් කරා. Structured question එක වෙන්න ඕනේ. Right? Omega and f. Omega is acting as y. හරි. එකපාරට මිස් වෙනවා මෙහෙම ලියා ගන්න. Omega is acting here as y and f is as x. Right? Subject y. Subject omega. Omega squared equals f over r. Then omega equals root f over r. Right? R is a constant. I'll be writing this as root r and root f. Right? Okay. Now identify variables. This is a standard shape. This is standard shape. This is y. And f is my x. This is root x. And whatever it is as a multiplier with the independent variable is gradient. M root x. So the standard curve is m root x. Right? M root x. What's the curve? Numbers in here. What's the correct curve? M root x. Online, quickly. What? Right? දැන් මම දවස් ගාණක් කිව්වා graph plotting තාම දන්නේ නැත්නම් මම කලින් batch එක කරපු මේ කලින් batch එක කියන්නේ කලින් theory batch එකේ කරපු මේකක් ඇති තාම තියෙනවා graph plotting session එකේ තියෙනවා. ඕක බලන්න. මේ තාමත් දන්නේ නැත්නම් graph plotting ඒකට ගිහිල්ලා බලන්න graphs 10ක් එනවා හොඳ. ලකුණු 10ක් එන ඉංග්‍රීසියෙම MCQs graphs 10ක් එනවා. හරි. 10 කියන්නේ හරියටම 10ක් නෙමෙයි. 9 වෙන්න පුළුවන්. Around 10 නා. There are around 10 graphs are coming in the paper. ඕනේ paper එකක් අරන් බලන්න. Around 10 graphs තියෙනවා. කෙලින්ම ලකුණු එන්නේ. Right? This is a standard curve m root x. මේක තමයි curve. 4 answer 3. Fifth one. The washing machine is operated with a motor of 320 watts and the rotating disc of it has a moment of inertia of 5 kg m squared starting from rest. How long will it take to acquire a frequency of 240 rpm under the above power? 5 squared is 10. What is rpm? Revolutions per minute, right? Revolutions per minute. If rpm is given, which means that omega is known, no? So we know omega is 25 rpm over 60. What is rps, by the way? මම හිතන්නේ කලින් paper එකක මම මේකත් කිව්වා. What is rps? Revolutions per second. It is also called frequency. ඉවරනේ කලින් paper එකක තිබ්බා. Right? This is also called frequency. Revolutions per second is frequency, right? RPM and RPS, right? So omega here is 25, RPM is 240 over 60. So omega is, simplify this, 85. Omega is 85. Moment of inertia is given, P is given, right? Tell me the relationship between power and velocity in linear motion. What is the relationship between power and velocity in linear motion? P equals Fv. P equals Fv, right? All linear motion equations can be converted to rotational motion, right? එහෙම තමයි rotational motion equations එක හැදෙන්නේ. That is how rotational motion equations are built. Now, as an example, in linear motion we have V equals U plus AT. In rotational motion, omega 2 equals omega 1 plus alpha t. Same equation, right? F equals ma in linear motion, torque equals I alpha in rotational motion, right? එකම විදියට යන්නේ. Half mv squared in linear motion, half I omega squared in rotational motion, right? So if P equals Fv in linear motion, see, if P equals Fv in linear motion, power is power anyway. P equals torque omega in rotational motion. P equals torque omega in rotational motion, right? So some say this tau is the symbol. Tau is a symbol. The term is torque. ඒක දන්නවනේ? Torque omega, right? Tau omega කිව්වත් කවන්න නැහැ. Tau කියන්නේ symbol එක. Symbol එක ලියන්නේ මෙහෙමයි. Tau, right? And the term is torque. මේ කන්න torque නෙමෙයි හොගේ. මේක නෙමෙයි. කන්න torque නෙමෙයි. TORQUE torque. Right. Now P is given 320. And we know torque can be written as I alpha. No? Torque is I alpha. ඒකත් මෙතනම අපිට දාන්න පුළුවන්. Torque is I alpha. I is given moment of inertia 5, right? Then 5 times alpha times I alpha omega. Omega is here 85, right? Now I'm going to find alpha, angular acceleration from this, right? This is 8 times 40, right? And this is 5 times 8. So alpha is 8 over 5. Alpha is 8 over 5. Now you need time. If you need time, apply a rotational motion equation. Do we know the initial velocity? Initial angular velocity. Do we know? Yes. Starting from rest. Final angular velocity? Yes. Here. Alpha, angular acceleration? Yes. Then time can be determined. In linear motion, V equals U plus AT. The rotational form of the same equation, omega 2 equals omega 1 plus alpha t. Omega 2 equals omega 1 plus alpha t. Omega 2 is 85, right? Omega 1 0, omega 1 is 0, plus alpha is 8 over 5 t, right? 85 equals 8 over 5 t. 8 to 8 cancels. T equals 5 squared. T equals 5 squared. 5 squared is given as 10. So answer is 10. For 5, answer 5. Who got the correct answer? Got it? Got it? No. Yeah? Adisha? Got it? Okay. So please ask if any questions, right? For this paper, you had more than enough time to write, right? If you are not affected, right? If you are not affected, now Wednesday, right? Now it's Monday. දවසකට MCQs 5 ගානේ කරත් paper එක කරලා ඉවර ගන්න පුළුවන්. SS 2යිනේ තියෙන්නේ. යට වුණානේ. ගම් වතුර ආදාර හම්බුණාද මේ මොකද අවුටින් එකක් මොකක් කර ගිහින් තිබ්බනේ අවුටින් එකක් මොකක් කර ගිහින් තිබ්බනේ Donations out in here. Unlike a photos are in Labana would never Labana would again the year. So, Masa time. Right. Clear? Next one. 6. Projectile motion. A cricket ball leaves the bat with a velocity of 60 ms minus 1, inclined 32 horizontal. After being hit, the ball lands on a distant roof as shown in the figure. Right. If the time taken to land on roof by ball is 5 seconds, height of the building h is. Any answers? 3. 25. Same. Okay. Right. So at once, what you can do is, see, this is an easy one. This is an easier one. Look at the board. Now it's going up to here, h. Right? 60 is given and this angle is 30. Right? So in the upward direction, we can use s equals ut plus half ad squared at once. Right? S from here to here is from this point to this point. S from vertical displacement from here to here is h. Right? U is 60 sine 30. 60 sine 30 is 30. Sine 30 is half. 60 sine 30 is 30. So that value is 30. 30 into 5. When we are applying upwards, g becomes minus. So minus half, g is 10. Right? Minus 5 altogether, 5 squared. Right? So h equals 150 here and 5 times 25, 125 here. 25 meters. 3. Eight. Sorry, 7. 7. A box of mass 5 kg is kept on a horizontal surface. A box of mass 5 kg is kept on a horizontal surface. Right? So if the mass is 5 kg, we know this is 50 newtons. And there's a reaction, say R. Right? Coefficient of static friction between the box and the surface is 0.3. Mu is 0.3. Friction force acts on the box when a horizontal force of 10 newtons is applied on it. Right? Now a horizontal force of 10 newtons is applied here. This mu is given as 0.3. Right? Okay. What's the answer you have got? Quickly. What's the answer you have got? Before I explain. 10. 10. 10. Online? See, I think from this type, I have discussed questions already, right? If you apply F equals mu R, right? What you are getting is only the which friction? Limiting friction. Only the limiting friction, because this equation is valid only for the limiting friction, right? Now, what you are getting if you apply F equals mu R is F equals mu is 0.3, R is 50, which means 15 newtons. The idea is there's a limiting friction of 15 newtons here, right? So this is the limiting friction. This is the limiting friction, LF. This is the limiting friction. Limiting friction here is 15. That's the idea. Limiting friction is the maximum friction that is possible at this surface, right? If the applied force is below the limiting friction, actually the object is at which region? Which region? Is it static or dynamic? Static, then which region? Which region? self adjustment region, right? Self adjustment region. Now in the graph, this is where it is, right? Friction with the applied force, right? Limiting friction is here. May friction if the applied force is less than that, friction is at the self adjustment region. Self adjustment. So which means friction is adjusted as it is meshed with the applied force. So therefore, since there is a static, F equals 10. So therefore, F equals 10 newtons. Right? F equals 10. Answer 4. මේ type එක මම කතා කරලා තියෙනවා. The thing to explain this is there are like a considerable amount of students who are applying F equals mu r at once and picking 15. That is wrong. ඒ හින්දාම තමයි මේ question එක අහන්නේ. අද ඉතින් මේක simplify කරලා බලන්න ඕගොල්ලන් අහන F equals mu r ඕනෙකට simplify කරගන්න ඕන. ඉතින් ඒ level ළමයකින් අහන තරම් ප්‍රශ්නයක් නෙවෙයි මේක. එච්චර මේක. හරි. මෙන්න මේ පොඩි thinking එක බලන්න තමයි ඔක check කරන්න ඕක අහන්නේ. ඔය type එකමයි එන්නේ. past papers වල බලන්න. ඔය type එකමයි එන්නේ. Right? 8. A person rotates a ball in a horizontal circle of radius r1 with an angular velocity omega 1 as shown. If he reduces the radius of circle to r2 without applying an external torque, mu angular velocity omega 2 is given by. If there is no external torque, which means what is conserved? What is constant? Angular momentum. Angular momentum is conserved. So use the conservation of angular momentum. Law of conservation of angular momentum. Right? So we know I1 omega 1 equals I2 omega 2. Right? Around any external point or about any external axis, moment of inertia can be written as mr squared at once. Right? I'm just reminding again. About an external point or an external axis, right? You can write moment of inertia at once as mr squared. Right? But if there is about an on point, always there is a coefficient that is coming in front of mr squared. Right? So in such cases, you can't assume that coefficient. That coefficient is a result of integration. Integrals කරලා දෙන්නේ. Integration result එකක් තමයි ඒක. Right? මේ maths අය බයෝ කරන අය integration කරලා නැතිද දෙන්නේ. ඔයගොල්ලොත් කරනවා first year එකේදීම campus ගියාට පස්සේ integration තියනවද? අර පොඩි gap එකක් තියෙන්නේ. එහෙම තමයි. බයෝ කරත් integration තියෙනවා. commerce කරත් integration තියෙනවා. differentiation උත් තියෙනවා. Simply all calculus is there. Calculus කියන එක ඕනම එකකට තියෙනවා. arts ගැන මම දන්නේ නැහැ. commerce වලට තියෙනවා. Right? Because most of the equations which has rate in it are done with the calculus, with differentiation and integration. Rates here, that is what integration is for. That is what differentiation is for. දන්නවනේ. If displacement is x, x dot gives the velocity, x double dot gives the acceleration at that point. Right? Rate එක නැවිල්ලා තියෙන්නේ. For any rate that is applicable. Right? In the equations ගොඩක ඉස්සරහට හම්බ වෙනවා. Differentiation, integration නැතුව මොකුත් කරන්න බෑ. Simply physics වල කොහොමද බෑ. commerce වලවත් බෑ. Right? medicine එකටත් තියෙනවා. මොනවද දන්නේ ඔයගොල්ලන්ට තියෙන equations. medicine කරත් ඒවා තියෙනවා. Right? If you are in a university where an engineering faculty is available, right? So you can get the help, get the support from the engineering students. එහෙම තමයි. අවෙත් එහෙමයි. අපේ නම් medical faculty එක අලුත්, but we had a business faculty recently, no? I mean before medical faculty. So අපි first year ඉන්නකොට තමයි first batch of business faculty came in. So then business faculty එකේ ඉන්න commerce කරපු අය. දැන් උන්ට ෆස්ට් ඉයර් එකේ ඉන්ටිග්‍රේෂන් තියෙනවා. ඩිෆරන්සියේෂන් උත් තියෙනවා. ඒතර අපිට A levels වල තිබ්බ ඒවා. ඒ කියන්නේ ෆස්ට් ඉයර් එකේ තියෙන ඒවා ඊට පස්සේ ඉතින් අනිත් ඇඩ්වාන්ස් කේස් උත් තියෙනවා. අර කුප්පි දානවා කියන අහලා තියෙනවා. මේ ඒතකොට ඉතින් අපි තමයි උන්ට කුප්පි දැම්මේ. ඒ කියන්නේ E fact එකෙන් තමයි B fact එකට කුප්පි දැම්මේ. B fact කියන්නේ බිස්නස් එක, E fact කියන්නේ ඉන්ජිනියරින් නේ තේරෙනවද? මේ ඒතකොට ඉතින් එහෙම තමයි උනේ. එහෙම වෙනවා. ඒතකොට දැන් අපිටත් මොනවා හරි කොමර්ස් අය දන්නේ ඒවා තියෙනවා නම් මේ අපි ඒගොල්ලන් උත් අහගන්න වෙලාවල් තියෙනවා. අපි අහගන්නවා. ඇත්තටම අහගෙන තියෙනවා. කියන්නේ අපිට account module එකක් තිබ්බා. economics. මොකද economics එහෙම මුළු දවසට එච්චර තේරෙන්නේ නැහැ. අරුන්ට කියලා තමයි කුප්පියක් දාගත්තා. එහෙම තමයි. So that coordination was there. හරි. මේ ඉස්කෝලේ වගේ නෙමෙයි හොඳේ. In universities supporting each other කියන එක හොඳටම තියෙනවා. ඉස්කෝලේ වගේ නෙමෙයි හොඳේ. ඉස්කෝලේ එහෙම නැහැනේ. ඇත්තටම ඉස්කෝලේ එහෙම නැහැ. ඒ environment එක ඉස්කෝලේ නැහැ. يعني ඉස්කෝලේ උනත් ක්ලාස් එකක උනත් සාමාන්‍යයෙන් වෙන්නේ ගර්ල්ස්ලා එක පැත්තක, බොයිස්ලා එක පැත්තක. එතනින්ම වැඩේ ඉවරයි. එතනින් ඊට පස්සේ එතනින් එහාට ආයේ මොකුත් නැහැ. ඇත්තටම කියන්නේ. මේ ඒක ස්කූල් වල නම් ඒක හැදින්නෙම නැහැ ඉතින්. ඒක මේ ශ්‍රී ලංකන් කන්ටෙක්ස්ට් එකේ තියෙන එකක් හොඳේ. ඕගොල්ලෝ ඉන්ටර්නැෂනල් ස්කූල්ස් බලලා තියෙනවා නම් ඒවා හැම ප්‍රශ්න නැහැ. මතර මේ ශ්‍රී ලංකන් කන්ටෙක්ස්ට් එකේ මේ ස්ටේට් යුනිවර්සිටිස් sorry ස්ටේට් ස්කූල්ස් වල එහෙම තියෙන එකක් නේ. හැබැයි යුනිවර්සිටිස් වල ගිය ගමන් ඒක නැහැ. හරි. මම දැන් ඔය කියපු නිසා මම එක එක්සැම්පල් එකක් කියන්නම්. අපි දැන් ෆස්ට් ඩේ ලෙක්චර්ස් ගිහිල්ලා හරි මේ ෆස්ට් ඩේ ලෙක්චර්ස් ගිහිල්ලා ඉස්කෝලේ ක්ලාස් වලයි පුරුද්දට බොයිස්ලා සෙට් එක පැත්තක වාඩිනවා. ඒ ගර්ල්ස්ලා ටික වෙන පැත්තක වාඩි වුණා. ලෙක්චර් ආපු ගමන් කිව්වේ බල ඉස්කෝලේ කියලා හිතුවද ෂෆල් වෙන්න කිව්වා. එහෙම තමයි. ඇත්තටම ඒක හැදෙන්න ඕනේ. ඉතින් ඒක ගියාට පස්සේ තේරෙයි. ඉස්කෝලේ කියන එකේ ෆ්‍රීඩම් එක නෙමෙයි ඒකට කියන්නේ. මම දන්නේ නැහැ. ඒක නෑ. ඒක නිකන් හරි. ඒ නිසාම තමයි ළමයින්ගේ අතර අර මේ පොඩ්ඩක් ඒ බොන්ඩ් එක අඩු. ඉස්කෝලේ ළමයින්ගේ බොන්ඩ් එක අඩුයි. හරි. ඒ කියන්නේ වාගේ සර්කල් එකේ ඉන්න කට්ටියවත් එක්ක ඉන්නවා. හැබැයි ඕවරෝල් බොන්ඩ් එක අඩුයිනේ. දැන් ක්ලාසස් 7ක් තියෙනවා කියනකො. මම දන්නේ නැහැ කීයද කියලා. A B C D මොනවා හරි තියෙනවනේ ක්ලාසස්. ඕලු නෙළුම් මොනවා හරි තියෙනවනේ. අන්නේ ක්ලාසස් 7 සෙක්ෂන් වයිස් ගත්තොත් කී දෙනාද කියන්නකො. අර බොක්කෙන් උදව්වක් කරන්න අඳුරන්නේ. එහෙම කට්ටිය අඩුයිනේ. You know your circle. It may be a gang of 5 people or 10 people or whatever it is. That you know. But as an overall, there's no such bond. Right? අරගෙන එහෙම නෙමෙයි. ෆැකල්ටි එකටම එකපාර කුප්පිය දානවා. එහෙම තමයි. ඩිපාර්ට්මන්ට් එක නම් ඩිපාර්ට්මන්ට් එකට එකපාර කුප්පිය දානවා. ෆැකල්ටි එකටම තියෙන මොඩියුල් එකක් නම් ෆැකල්ටි එකට එකපාර කුප්පිය දානවා. කෙලින්ම අපේ මොකක් හරි හෝල් එකක් අරගෙන. එහෙම තමයි. That is there. Right? සමහර සබ්ජෙක්ට්ස් තියෙනවා. දැන් ඩිපාර්ට්මන්ට් සබ්ජෙක්ට්ස්. හරි ඩිපාර්ට්මන්ට් එකක් කියන්නකො. There are 80 students in our department. සමහරලාට ඕක තේරෙන්නේ එක්කෙනෙක්ට වගේ. මොඩියුල් එක. ඒ කියන්නේ එදා ලෙසන් එක. ඒ එක්කෙනා ඊටු හැමෝටම කුප්පියක් දාලා කියලා දෙනවා. අන්න ඒ ලෙවල් එකට තියෙනවා. හිතන්නකො ඉස්කෝලේ එහෙම වෙන්නේ නැහැ. ඉස්කෝලේ දැන් ෆ්‍රික්ෂන් කරනවා. ඔයාට ෆ්‍රික්ෂන් තේරුණා කියලා ඔයා මුළු ක්ලාස් එකටම ෆ්‍රික්ෂන් කියලා දෙන්නේ නැහැ. කියලා දෙන්නේ නැහැ. කියන්නේ ඒ බොන්ඩ් එක නෑ ඉස්කෝලේ කියන එක. පර්සනලි කාගවත් තරක් දන්නේ නෙමෙයි. මේ බොන්ඩ් එක හැදෙන්නේ ඉස්කෝලේ ෆ්‍රීඩම් එක දෙන්නේ නැහැ. ඒක අර අතනම අර ස්ටීරියෝටයිප්ස් කියන්නේ. ඒ කියන්නේ දන්නවද ස්ටීරියෝටයිප්ස් කියන එක අහලා තියෙනවද? gender biasness and stereotypes තමයි එතන තියෙන්නේ. first thing. එතනම ඒක ඉවරයි. එහෙම තමයි හැදෙන්නේ. Okay. ඒ වැඩන්න මේ what I was telling was even if you are doing biomaths, right? Bio ගන්නට දැන් නැහැ. For A levels you don't have, but when you are in the university you will see calculus subjects. Combined maths වල තියෙන පාඩම් ගොඩක් තියෙනවා. මෙඩිසින් වලට. right? يعني එක එක equations වලට නේද? දතක් ගලවන්න හරි බෙහෙත් දෙන්න හරි equation නැද්ද දා ඉන්නේ නැහනේ. ඒක මොකක් හරි මේ ඔයගොල්ලන්ගේ තියෙන rates තියෙන rate calculations තියෙනවනේ. අන්න ඒවට තමයි ඒක use වෙන්නේ. right? About an external point I can be written as mr squared. About an external point I is mr squared. Then I1. This is the same ball. So I will consider that mass as m. M r1 squared omega 1 equals this is m r2 squared omega 2. M2 m cancels, right? But we need this omega 2. Omega 2 ne? Subject omega 2 from here. Omega 2 equals r1 squared omega 1 over r2 squared, right? this square can be taken out, R1 over R2 whole thing squared, omega 1. R1 over R2 whole thing squared, omega 2. So 8 answer 2. 9. Three liquids of different densities, rho 1, rho 2, and rho 3 are in a U-shaped container. Which of the following equation correctly represents the relationship among densities? Right. See, question 9. Okay, first tell me how many liquid interfaces are here in this given diagram? How many liquid interfaces? How many liquid interfaces in the given diagram? (15 and 10). Right, I'll explain this one as well. Right. How many interfaces? 2. There are 2 interfaces. Right. How many interfaces with equal pressures? There are 2 interfaces. That is correct. Now, next question is how many interfaces with equal pressures? Online? That's the point you need to understand here. How many interfaces with equal pressures? Online students, respond. Put it to the main chat. Yeah. 3. There are 2 interfaces, and out of 2, there are 3 interfaces with equal pressures. Contradictory. Total how many? යන්නේ ඉතින් හරිය අතරදුනත් ඉතින් නවාටනේ අපිනේ 1 මොකද 1. What about online? Quickly. You should be confident about the answer you are giving, right? Theory class එක කට්ටියට නම් ඉතින් මොකුත් කියන්න නැතුව ඉන්න බෑ කොහොමවත් මේ type A questions මම කරා interfaces 4ක් තියෙන ඒවත් කරාද කොහෙද නෑ 3ක් කරා. How many interfaces with equal pressures? 1. Right. See, so this is one of the interfaces. This is one of the interfaces, and this is the second of the interfaces, right? If there are equal pressures, it should be the same consistent liquid in both sides of the interface, right? That is how it's proved. If there is the same consistent liquid in both sides of the interface, pressures are equal. If not, pressures are not equal, right? Now, if you consider this interface, what are the names given? Rho 1, rho 2, and rho 3 again, right? See, rho 3, rho 2, and rho 1. This is the interface between rho 3 and rho 2. But this side, the liquid is rho 1. 2 different liquids at either sides of the interface. So that is not equal in terms of pressure. That is not equal, right? Now, if you consider here at this interface, rho 1 and rho 2 liquids are here, and at this side, rho 2 is here. So this is a consistent liquid. Consistent means unbroken. This is an unbroken liquid, right? You get that? මෙතන මැද වෙන liquid එකක් දාලා දෙපැත්තේ ආයි මේක තිබ්බත් වැඩක් නැහැ. It should be unbroken. It should be consistent. එහෙම නැත්නම් pressure වෙනස් වෙනවා, right? So therefore, only interface that you can consider to equate pressures is this one, even though there are 2, right? So So this is the only possible one, right? So let me label this as A and B. Therefore, PA equals PB. උඩ එක equal කරලා ගත්තොත් එන answer එක ඔතන ඇති. ඒක වැරදි. PA equals PB. Pressure at a point is H rho G, right? Atmospheric pressure එකත් එක්ක ලියනවා නම් P naught. P naught plus which is 15 rho 1 G. We are here at A, and from this side there are two liquids to go through, right? First one P naught through the first liquid, 10 rho 3 G through the second liquid. If this is 15, this is 5, no? 5 rho 2 G. P naught to P naught cancels, G to G cancels, right? Divide the whole equation by 5. 3 rho 1 equals 2 rho 3 plus rho 2. 3 rho 1, first one. For 9, answer 1. Right? Ten. Ten is also a good question. A solid cylinder rolls to the right on a rough horizontal plane without steering. Direction of velocity at point O on the circumference is right. Okay. Right. Say this is a rolling wheel, omega and V. This is a rolling wheel, right? So without explaining about point O, I'm going to explain using few other points. Look at here. Right? Look at here. This is a must-know concept, right? මේ විදිහට විතරයි මේ velocity එක direction එක හොයන්න පුළුවන්. Right? Look at here. Now, what actually happens if it rolls is, you know, this bottommost point is at a momentary rest, no? Right? That is at a momentary rest. And for all other points, they have a velocity, right? This is how this velocity comes. Now, from the linear velocity, this same linear velocity is there at any point on the circumference, right? This same linear velocity. This same linear velocity is on the any point of circumference, right? So that is how a linear velocity impacts on a body, because if I'm moving this with a velocity v, each and every particle of this pen is also moving with v, no? So therefore, that linear velocity matters, that impacts on each and every particle on this with the same direction, same magnitude. So here also there is v, here also there is v, like this, right? And from omega we know there's another velocity component comes. අපි අර spinning ball question එකක් කරා නේද? මම ඒකෙත් කිව්වා. From omega, tangential velocity comes. Tangential velocity is along the tangent, right? That is along the tangent. So this direction is along the tangent. I'll be labeling it as VT, and this one is along the tangent VT. Along the tangent, this direction VT. Along the tangent, make a rotational direction VT. So this is how the tangential velocity comes. And actual velocity of any point of this wheel now is the resultant of these two, right? That's the resultant. So therefore, if you need to find the actual direction of the velocity here, the resultant of these two, Vt and V, right? And from here we know, this is the logic. Since this is at a momentary rest, right? We know Vt equals V, right? Vt equals V, which means these two velocities are equal in magnitude, right? So therefore, resultant is exactly in between, right? This resultant is exactly in between. Got it? That's the direction of velocity, right? That's the direction of velocity. And always this resultant will be perpendicular with the grounded point, say point B, no, A, right? This is always perpendicular with this one, right? Angle check karot mega hoga na. About this velocity also, see, this is also perpendicular. So therefore, actual velocity occurs at a perpendicular direction to this point. The reason is this, actual reason is this. If there is a rolling motion, what is the point of rotation? AO, OO, B. What is the point of rotation of this object at this moment? What's the point of rotation? Point of rotation. AOB. What's it? What's it? A. Point is point A, right? So if it rotates about point A only, it rolls. If it rotates about point O, it doesn't roll, it rotates. That is called a rotational motion, rotating. This is not a rotating, this is a rolling motion. Right? Rolling motion, that is why this point is at rest. Right? So therefore, if this is the rolling point, this is how these particles are going to roll around. See, this is how these particles are going to roll around. So therefore, if you extend this line, if you connect the line from here to here, this velocity will be perpendicular with this connecting line. Right? That's a logic. That's a logic. The logic make use now a random point is given. Right? So if you don't know this theory, take this down quickly. Right? And now you can do the construction. Construction point perpendicular. Get the most bottom point and draw a line and check the perpendicular direction. That perpendicular direction is the direction of velocity. Right? Know the correct logic. Logic එක දන්න නැතුව දැන් මේක හිතලා කියන්න බෑ හොඳේ. That's a logic. That's a logic. හරි මට හොයලා දැන් ආන්සර් එක මොකක්ද කියලා කියන්න. Quickly. So before I do, if you don't know this, you can take this down. This is since momentarily rest. Since momentarily rest. This is about point A. That is about point A. Please put your questions to main chat if there is not something personal. So if that's personal, you can drop it as a personal message. Okay, now here, what's the answer? Balloon, construction ekala balloon. What's the answer? Don't copy it down, right? This is the point O given, right? Connect this line, and always velocity is perpendicular with the line here, with this connecting line with this point. More than OC, OB, OC, OC, right? OC, right? So that's the logic. OC, for 10, OC. That's the logic. Write down below with the red pen. Write down below with the red pen. Direction of velocity. Direction of resultant velocity. Direction of resultant velocity. Direction of resultant velocity. Direction of resultant velocity is perpendicular to connecting line, perpendicular to connecting line with point of rotation, at the moment, with point of rotation at the moment, within brackets A. within brackets A. Within brackets A. Right? Listen again. This is a good question. Huh? Listen again. In a rolling motion, point of rotation is always the bottommost point. Right? In a rolling motion. Because if this rotates about point A only, it travels forward in the very next point. Right? Otherwise, if it is going to rotate around point O, it doesn't travel forward. It doesn't travel in the forward direction. Right? So therefore, always the point of rotation in the rolling motion is the bottommost point. Right? That is why it should be momentarily rest. Otherwise, if it slips, right, the system will slip. This is rolling without slipping. Rolling without slipping. Right? So that's the point. If there is not slip, which means Vd equals V. If V is greater than Vt, what happens is it slips in that particular direction. Right? So from that we know these velocities are equal. Since these velocities are equal, now if I consider these main points, these four main points, their velocities are, this is horizontal and this one is 45 degrees inclined with this direction, this is 45 degrees inclined with this direction, and this is 0, right? So similarly, since the point of rotation is A, right? So we know in any rotational motion, if the rotation is around point O, right? If the rotation is around point O, if you connect it with the tangent, right? If you connect it with the tangent, direction of velocity at the tangent is always perpendicular with the connected line between direction of with the point of rotation and the circumference. No? Same thing. Now for this moment, this point is acting as the point of rotation. Then if I consider this point, it rotates around this kind of a circle. So that's why it is perpendicular with the line which connects from here. Right? Now this actually rotates about a circle which has something like this. Right? Radius circle point again for that moment. And the complexity of this rolling motion is that point changes from second to second, from millisecond to millisecond. Right? It changes when this rotates around. Right? 11. The figure shows a spinning ball traveling horizontally. A perpendicular lateral force is exerted on ball due to air drag when it spins. What is true regarding this? Okay. About these given streamlines, also there is something you should know about the given streamlines. About the given streamlines, also there is something you should know, right? Listen, when we draw streamlines, if you need to show a higher velocity, are we drawing it closer to each other or much closer or apart from each other? What about it? Drawing standard, that's a standard that we have in the drawing. This gap is higher than this gap, right? Lower gap means higher velocity, higher speed, right? Velocity gap. That's the standard we have when drawing streamlines, right? So therefore, this gap is lower. This gap is lower means this velocity is higher. This velocity is lower. Higher the velocity, what about the pressure? Lower the pressure, right? Last week last week the week before the last week. Higher the velocity, lower the pressure. Lower the velocity, higher the pressure. Right? Always that force exerts from force exerts from which pressure to which pressure? High to low, right? High pressure to low pressure. Force exerts from high pressure to low pressure. So therefore, direction of this force is going to be from high to low, that is vertically upwards. Right? Yes, rotational direction okay. See? Yeah, rotational direction direction of motion of ball easily if direction of the airflow is to the right, direction of motion of ball is to the left. Right? Direction of airflow is to the right, which means direction of rotation, direction of linear motion of the ball is to the left. Right? So that is how it penetrates the air medium. Now, last week, when the ball travels to a particular direction with the equal and opposite speeds, the airflow travels in the opposite direction, other direction, right? And about the rotation, now we know if this point is having a higher velocity, which means this should be having both linear velocity and tangential velocity to the same direction, right? And this should be the point having the direction of linear velocity and the tangential velocity in opposite directions, right? Last week MCQ right? Now, if the tangential velocity is this way, which means rotation of this ball is going to be like this. Rotation of the ball is like this. That is anti-clockwise, right? Then direction of motion of ball is leftwards, right? Leftwards, counterclockwise. Answer correct the second answer as direction of force upwards. The answer correct the second answer as, only the direction of force. Correct the direction of force in the second answer as upwards. And consider that as the correct answer. That's a mistake, typing mistake. Right? So it should be moving direction is leftwards. Right? Rotation is counterclockwise. And force is upwards. Well, right? A container of water is hung by a spring balance and it reads 10 kg at this occasion, right? What is the reading of a spring balance? Balances cannot questions. Then papers clear clear correct. Balances question fan balance and spring balances what is considered as a reading of a spring balance? Yes. Tension of hook, right? Tension of hook. Tension of hook, right? Reading of spring balance when the iron block of mass 7.2 kg is half immersed by means of a string. Relative density of iron is 7.2, right? Okay. Sit. First tell me, if the iron block is immersed, is it going to be, reading, is the reading going to be increased or decreased? මේ logic එකත් මම මේ class එකේ කලින් කියලා දෙනවා. Is it going to be increased or decreased? If this iron block is inserted, is this reading going to be increased or decreased? Increase. I know. Increase. Increase or decrease? Increase. Increase. Same. What's the reason? What about online? Increasing or decreasing? What's the reason? last set these are logical subject. Logic क्या තියෙන්න ඕන? What's the logic? Logic එක මම කියලා දෙනවා. ඒකයි මම බය නැතුව අහන්න. What's the logic? අර tension එක increase වෙන්නේ නැහැ කියලා තමයි කියන්නේ. That I know. Then if the reading increases, yes, tension increases. What's the reason to increase tension? ඒක තමයි logic. හා? නෑ. අන්න ඒක තමයි මම අහන්නේ. What's the reason to increase tension here? That is not the up thrust, but down thrust. Down thrust එක කරනවා කිව්වා. That is a down thrust. Up thrust is on the body, on the object. Down thrust is on the container. Container එකේ system එකේ force එක වැඩි වෙන ඉඳ තමයි tension එක වැඩි වෙන්න ඕනේ. Because these are separate system now. මේක වෙනම string එකකින් එල්ලලා තියෙන්නේ. Right? So when up thrust exerts on this one, at the same time the down thrust exerts on the container, on water, right? So therefore, now initially this T and this mg that we know actually, that is 10 kg, no? 10 kg, no? 10 kg means 100 newtons. So initially T and 100 was equal because there was no down thrust, right? And now this is the force, these are the forces which belongs to the container. These are the forces which belongs to the container, right? So therefore now T equals 100 plus u. Mu T is going to be, see, mu T is 100 plus u because of the down thrust, right? So initially the reading was 10, then it is greater than 10. මේක දැන් දන්නවනේ. Since there is a down thrust, that is greater than 10. Less than 10 තියෙන answers අයින් කරන්න. First is wrong, right? First එක විතරක් ඕන අයින් කරන්න පුළුවන්. First is wrong. First one is wrong. 10 වෙන්න බෑ. It is greater than 10. Right? Now I'm going to find this down thrust separately. See? Down thrust and up thrust are equal and opposite forces. They are mutual forces which follows Newton's third law, right? V is not given, instead mass and density are given, no? So we know m equals 0. If m equals 0, V is m over rho, right? So this can be written as mass over density times density of liquid into G, right? Mass is 7.2, right? And this is immersed in water, right? In water. And relative density is given. Relative density is 7.2. Relative density is the ratio between the density of object and density of water, right? එකපාරින් ඕන නම් මෙහෙම substitute කරන්න පුළුවන්. See? Relative density is rho over rho w. That is given as 7.2. Now rho L is rho w, no? Now what I need is rho w over rho O. That is 1 over 7.2. Right? Then for this part at once, I'm going to substitute 1 over 7.2 into 10. So U is 10. U is 10 newtons. Right? 10 newtons. The new tension is, see, new tension is 100 plus 10. New tension is 110 newtons. 110 newtons. Sorry, half immersed. Half immersed. Then this is the total volume. This is the total volume into half. Half immersed, it's given, right? Half immersed. Then this is only 5. Half immersed, right? So this is 5 newtons. 5 newtons. 105 newtons. So new tension in kilograms is 10.5 kilograms. 2. Answer 2. Right? Fish. 13. හැමදාම පොඩ ඉන්නවා මයික් එක මියුට් කරලා ඉන්න පස්සේ. 13. The best graph that represents the variation of the frictional force F with increasing force P applied to the inclined plane on the object kept on the rough plane is right. Now, from the theory, what you know about this occasion is this one. No? This is what you are learning in the theory. This is what you are learning in the theory. Variation of friction with the applied force on a horizontal surface. So, this you know. Having this basic understanding is needed here, right? This is what happens if there is in a horizontal flow, right? Now, instead, the modified part in this question is instead it is given in a inclined plane, inclined flow, right? That's it. See, theta and P is applied. See, okay. P is applied and that force starts from 0. Applied force P starts from 0. You can see it from the diagram, from the graph actually, not the diagram, from the graph. So P is starting from 0. Right. So we know if there is kept on the inclined plane from this mg, this component acts along the plane. No? This component acts along the plane. Right. Now, if P is starting from 0, right, there will be one phase of the system as when P is less than mg sin theta, no? Right? When P is less than mg sin theta. If P is less than mg sin theta, what's the direction of moving tendency of this object now? Quickly. What's the direction of moving tendency of the object if P is less than mg sin theta? Downwards the plane, which means friction is going to be upwards. Let's say F1, it is going to be upwards. So in this scenario, friction is going to be upwards, right? And as a second scenario, if P is increasing, right, at one point, this will be reaching mg sin theta, isn't it? Now, what's the direction of moving tendency when P equals mg sin theta? Direction of moving tendency. Moving tendency means at rest. Motion moving tendency. What is the direction of moving tendency? Now it's no moving tendency. Moving tendency because P equals mg sin theta. No unbalanced force. No unbalanced force means there's no moving tendency. If there's no moving tendency, what's the value of friction here? 0. Friction is 0 now. And third scenario, third scenario, now if P is increasing, right, at the very next point, beyond very next point, P will be greater than mg sin theta. If P is greater than mg sin theta, what's the direction of moving tendency? Upwards now. If there is upwards, friction switches, friction alters, it changes. Say F2, now friction will be downwards, right? Since there is a vector, if direction changes, positivity and negativity changes, right? So only possible answer is 5. Only possible answer is 5. Then this is upwards initially, downwards finally. Then direction difference, then friction should be plus and minus in both sides, and it's becoming 0 in between. 5. Plus and minus the answer check කරානම් කෙලින්ම answer එක. Check කරානම් කෙලින්ම answer එක. There's only one answer with plus and minus, right? 13, eh? For 13. Right? මේ දෙක direction එක මාරු වෙනවා කියලා විතරක් check කරගත්තා නම් ඒත් ඇති. Because only one answer is given with plus and minus values of friction. Right? So if direction changes, sign changes. If direction changes, sign changes. That's a vector. That's a vector. Next one. Velocity time graph relevant to the upward motion of an elevator is shown in the figure. Upward motion, no? Upward motion of an elevator. Direction matters and it's important. Motion is upwards, motion is upwards. A weight is kept on a top pan balance in it. On a top pan balance in it. Right? Pan balance is going. What's the reading of a pan balance? What's the reading of a pan balance? Huh? What's the reading of a pan balance? What is considered as the reading of a pan balance? Huh? No, not the term. That's not the term. What's the reading of a pan balance? Very comparative with the spring balance. In spring balance, the reading is tension of hook. On a pan balance, reading is reaction on pan. Reaction on pan. Right? Reaction on pan. Now, when this is kept, there will be two mutual reactions exerting on the body and the pan. Right? So, this is considered as the reading of the pan balance. Right? Not the resultant. Reaction on pan. Resultant kill reaction on pan. Right? Okay. Now here there are three phases. No, there are three phases. In first phase, velocity time graph is given, right? A positive constant inclination is given, which means there is a positive constant acceleration. Then in the first phase, it is accelerating. The body is accelerating upwards, right? The body is accelerating upwards, right? Now considering that, say this weight is W. Say this weight is W. Go to apply F equals ma upwards to check the first phase, to check the first time interval, first phase. So F is say R1 in the first scenario, R1 minus W equals ma. Now R1 equals W plus ma. W plus ma, right? You can do the same for other scenarios. In the second scenario, it's a uniform velocity. Uniform velocity means acceleration is 0. In the second scenario, acceleration is 0. If acceleration is 0, R2 equals W. No acceleration. Forces are equal. Right? And the third scenario, there is a deceleration. But the slope in that deceleration is greater than the slope in the acceleration. No? Right? So which means as a magnitude of deceleration is higher. Magnitude of deceleration is higher. Alright? Because gradient is tan theta. Higher the slope, higher the magnitude. Right? So magnitude of that deceleration is higher. So let's say this is A and deceleration I'm going to consider as A dash. Now in that case, there is an upward deceleration. Something like this, no? Upward deceleration. Right? Upward deceleration is equivalent to, this is equivalent to a downward acceleration. Right? Now, considering that, I'm going to use F equals ma downwards. Then W minus R3 equals ma dash. Right? Subject R3. R3 equals W minus ma dash. So these are the three values of these three readings at these three time intervals. Right? The first one is anyway greater than the mass, right? First one is greater than the mass. Second one is lower than the mass. And since A dash is, this is another decision you have to make. Since A dash is greater than A, right? This subtracted value is greater than the added value here, right? So which means R3 is minimum compared to this value, compared to R1, right? So what's the correct reading? 1, right? So that's the difference between, that is how you should break the tie between 1 and 2. Then 1, 2 tie right? So that is how you should break the tie between 1 and 2. 1 is the correct answer. Because this subtracted term is higher compared to this added term here. Logic clear on? So, first one. 14 first one. 15 නම් මම කරන්න ඕනේ නැති වෙයි. 15 එක නම් last week එකේ තියෙන paper එක මේ question එකක් තිබ්බනේ. තිබුණේ? 15 එකේ answer එක මට කියන්න. Okay. Right. Next one. 15. What's your answer? 15 මං කරන්න ඕනේ. 15. 3. C. Cද? Cද? 15 එක? Dද? දැන් ඉතින් හරියට ඇඳලා බලන්න ඕනේ. ඇඳලා බලන්න. Do the construction and see. දැන් ඕක හරියට අදිද්දි C එකේ වගේ අත ගහනවා නම් එහෙම අදින්න බෑ හොදේ. එහෙම බෑ ඕක හරියට තියලා අදින්න ඕනේ. පොඩ්ඩක් වෙනස් වුණොත් නැත්නම් වෙනස් වෙයි යා. 4. 4 කියලා මේකෙත් තියෙනවා. From this type, I have explained like 2-3 questions in previous papers. Yeah, I think it's D. D නෙමෙයි? D නේ? Show me the diagram. So if that is not exactly going through a point, consider the closest point. Close in the yeah, it is closer to D. It is closer to D. So therefore, consider it as D. It is close to D. Close to D. Okay. Do the construction, and it's an equilibrium under three non-parallel forces. It's an equilibrium under three non-parallel forces. That's it. Right? All three forces should be intersected at the same point. They should be concentric. Did they? Yeah. Right. දැන් මේ පාර ආපු center of gravity question එක ඔය ඔක්කොම වඩා ලේසි. ඒක දැක්කනේ මම කිව්වද ක්ලාස් එකේ? නෑනේ. කිව්වද? නෑ. මේ පාර ආපු center of gravity question එක ඔක්කොම වඩා ලේසි. Anyone who has the Pasindu book of mechanics right now? No. Right? කලින් ඒ question එකම ඇවිල්ලා තියෙනවා 2004 වල. ඊළ check කරලා බලන්න. I'm referring to the center of gravity question this time. It's D, right? Either C. No. Since that doesn't go through an exact point, take the closest point, right? It should be D. The same question has come in 2004, right? Amage center of gravity tube take see. Look at here. Now this is the center of gravity question which came this year, right? Look at here. Center of gravity. See? Oh, it seems it's not in the laptop. My phone gets on. One second. I'm going to show you the question that came this time, just 2 weeks before, right? Yeah, it's 94. 94 වල ආපු Pasindu question එක තියෙනවා නම් බලන්න පුළුවන්. It's 94. මෙන්න මේක ඇවිල්ලා තියෙනවා. See? Look at here. Rotate කරන්න. See? This has come. දෙන්නේ නැහැ නේ. Oh my god. ඉස්සරහට නැමෙලා ඉන්න මිනිස්සෙක් තියෙන්නේ. right? මෙන්න මේක question එකක් තියෙනවා 94. right? 94. මෙන්න මේක question එකක් තියෙනවා. right? මේකේ center of gravity එක කොයිද කියලා අහලා තියෙනවා. 94 ah. 94. Now this is 25. How many years? 30. 31 කියන 30. After 30 years, now the same question has come. This time question එක මේක. මෙන්න බලන්න. ඒ question එක lab එකේ තියෙනවා. past paper එක කරලා තිබ්බා නම් ඉතින් ඒ question එක කරන එක ඇත්තටම nothing. මෙන්න මේ පාර question එක. Can you see? May power question. What's the difference? May this time මම මේ paper group එකේ දාලා ඉතින් phone download කරගන්න. මේ this time. Right? මම මේ group එකේ දැම්මා. දීලා තියෙන points එක පේනවනේ. That's the exact same question. Exact same question. Rare incidence එක same question එක එනවා කියන එක it's rare. Right? But this time it happened. Right? 94 ලා ඇවිල්ලා තියෙන question එකත් එක්ක check කරලා බලන්න. Right? With the 94 center of gravity question. Right? Only difference is in 94 question the person is holding the toes. Right? Holding toes. It's right. But now he can't hold the toes. මෙන්න මේ වගේ ඉන්නේ. Same thing. Come diagram එක. මොකක්ද answer එක? මම නිකන් diagram එක අදින්න මම නිකන් අහන්නේ මේ question මේ 25 question එක. මම 25 එක අහන්නේ. මෙන්න මෙහෙම diagram එකක් දීලා තියෙන්නේ. Something like this. The person has bent like this, and he is holding hands, not holding actually, keeping hands like this. And roughly, right? And given points are that's a hip. ABC මාරුල ඇතිවද මට නිකන් කියන්න. Right. Now from these points, what is the center of gravity of this person? What is the center of gravity of this person? How many rough diagram I can do? What do you think? 25 question. Last question. Latest question. Now, if you are standing, at which point your center of gravity is? If you are standing still, at which point? කලින් දවසක් බඩේ නෙමෙයි. කිව්වනේ කලින් දවසක? At which point? මං හිතනවා ඇඳත් එක්ක diagram එක. At which point? Hip එකේ. That's the center point of hip. Right? මං එදා hip එකයි waist එකයි කියන එකත් එක්ක මොකක් හරි කිව්වා ඒ දෙක ගැන. Okay? Yeah, it's at the hip. Right? Hip hop නෙමෙයි hip. Right? That is at the hip. Now, if he bends in this direction, right? Then what's the displacing direction of center of gravity? Forward now? Is it forward or backwards? Always center of gravity moves towards the heavier side. Then now if we are standing still, center of gravity is at the hip, right? Now if I expand hands in this direction, what's the direction of motion of center of gravity? That particular direction. Backwards. Now if that person bends forward, forward down, then it is either B or C, no? Right? So how to finalize, how to break the tie between D and C? When logic if someone falls down, right? If any object falls down, the requirement to fall an object is center of gravity is moving out of the supporter surface, right? If the center of gravity moves away from the supporter surface only, it falls, right? Now as an example, center of gravity of this pen is around the center, right? Supporter means, now in this case the supporter is here. Explain supporter means that is the part which is in contact with the other mutual surface, that is called a supporter, right? If the center of gravity and acting line of weight is inside the supporter, this equilibrium is stable. If there is at the edge of the supporter, this is neutral, and if this is at outside the supporter like this, it is unstable. It is going to topple. It is going to fall, right? So therefore, if this person is standing without falling, which means still his center of gravity and active line of weight should be inside the supporter. So therefore, it should be a line which goes through the supporter foot. So therefore, it's B. It's only B. Right? එයා C වුණොත් එහෙම ඉන්න බෑ. මෙයා පෙරලෙනවා. කළා බලන්න. කළා බලන්න. ඉතින් බෙල්ල කැඩෙන්නේ නැහැ නේ ඔක්කරාගේ. කළා බලන්න. මේ පැත්තට නැමිලා ඔයාගේ සපෝටර් එකෙන් පැන්න ගමන් center of gravity එක මේ පැත්තට වැටෙනවා. Right? That's the thing. හරි? මේ 25 question එක. දැනගෙන ඉන්න ඕනේ. හරි? මම දැන් මේකත් එක්ක මතක් කරේ එකයි. It's B. මේකම තමයි අවිල්ල තියෙන්නේ. 94 question එකත් එක්ක බලන්න. ඒකේ දීලා තියෙන්නේ මේ පොයින්ට් එකට B මයි. මේකමයි අවිල්ල තියෙන question එක. Same. Right? All right. Think about this kind of a scenario. Listen. Think about this kind of a scenario. Okay. Listen. මේ අලුත් question එකක් අහන්නේ. මේක ඇවිල්ලා නැහැ හොඳේ. මේක ඇවිල්ලා නැහැ. මේ අලුත් එකක් අහන්නේ. මට හිතලා කියන්න. Right? මේ වගේම scenario එකක් අහන්න යන්නේ. ඇවිල්ලා නැති එකක්. Have you seen pregnant ladies? Pregnant mothers, ladies නෙවෙයි නේද? mothers. Right? දැකලා තියෙනවනේ. When she is pregnant, right? Then heavier side will be the what? Stomach, no? Right? වෙනවනේ. ඒක කොහොමද? මේ පැත්තරනේ weight එක add වෙන්නේ. නිකන් හිතලා බලන්න මේ practical scenario එකක් හොඳේ. මේ practical scenario එකක්. මේක ඇවිල්ලා නැහැ. Think about a pregnant mother. Right? Pregnant mother. Now, by the time, what happens is when that baby grows, when the baby grows up, weight of the tummy in this side is increasing. When it increases, now what can you say about the center of gravity of the mother now? What the displacement? What's the direction of displacing of the center of gravity? Forward or backwards? Forward. But මේ පැත්තෙන් එනවා අඩුයිනේ. වෙන්නේ. So it's forward. ඒතර ඕක බලන්න පුළුවන්. ඕක notice කරන්න පුළුවන්. ඕකේ තියෙන physics එක මේ හරියට observe කරොත්. When it moves forward, right? So it is getting closer to the supporter surface. ඒතර දැන් foot එකේ supporter surface එක. foot එකෙන් එහාට ඒක පැන්නොත් එයා වැත්තට වැටෙනවා. She is becoming unstable. So therefore, haven't you seen that they are naturally trying to bend backwards when they walk? අර මෙහෙමනේ යන්නේ. ඒ කියන්නේ හිතලා නෙමෙයි කරන්නේ. That's the physics behind it. I think දැන් බඩ මේ පැත්තේ ලොකු වෙද්දි මේක ප්‍රෙග්නන්ට් මදර් කෙනෙක් නෙමෙයි ඕක බඩ ලොකු මිනිස්සෙක්ට උනත් හරි හොදේ. weight එක අඩු වෙන්නේ. ඒකයි මම අර ප්‍රෙග්නන්ට් මදර් කෙනෙක් කියන එක ගත්තේ. weight එක වැඩිනේ. දැන් child කෙනෙක් කියන්නේ එතන සාමාන්‍යයෙන් 3 kilograms විතර weight එකක් ඇඩ් වෙනවනේ. හරිද? So naturally, center of gravity displaces forward. So therefore, naturally, the person tries to bend backwards. බලන්නකො හොඳට අදින් පස්සේ යද්දි ඒගොල්ලෝ මේ අපි යනවා වගේ මෙහෙම නෙමෙයි නේද? එහෙම යන්න බෑනේ. ඉතින් එහෙම යන්න බැරි අරගයි unstable වෙනවා. හරි? ඒ කියන්නේ අමාරුයි. ඒ වුණාට දැන් stability එක තියෙන්න බෑ. To keep that stability, they bend this way. මෙහෙම වෙලා යන්නේ හොඳට බලන්න. ක්ලිනික් එකක් එහෙම ගාවෙන් යද්දි. Right? So that's the thing. That is not something they are doing intentionally. Unbalance වෙද්දී ඒක කරන්න වෙනවා. Right? That's the thing. ඉස්සරහට යන weight එක counter balance වෙන්න මෙහෙම වෙනවා. හරි? ඒකත් මතක තියාගන්න. Right? එහෙම occasions අහන්න පුළුවන්. එහෙම questions ඇවිල්ලා නැහැ. හිතන්නෙත් නැහැනේ. දැන් pregnant mother කෙනෙක් දැක්ක කියලා center of gravity එක ගැන මං හිතන්නේ නැහැ ඔයගොල්ලෝ හිතනවා කියලා. මේ හිතන්නේ නැහැනේ. හැබැයි ඇත්තටම අර පිටිපස්සට ඒගොල්ලෝ නැමිලා ඉන්නේ ඒක අමාරුයි. ඊට පස්සේ මේ කියන්නේ back pains එනවා හොඳේ. කියන්නේ ඒක එනවා. අමාරුයි කරන්න දෙයක් නැහැ. දැන් ඊට වඩා unstable ඉන්නවා කියන එක ඊට වඩා ප්‍රශ්නයක් නේ. මෙමුණොත් එහෙම වැටෙනවනේ. ඒතකොට naturally එහෙම වෙනවා. naturally they bend. හරි. ඉතින් එහෙම bend වෙලා ඉඳලා ඒතකොට මාස 6ක් විතර මේ පැත්ත back pains එනවා. මේ අම්මලාගෙන් අහලා බලන්න. ඒ කියන්නේ even after the delivery they have these pains. Right? එහෙම තමයි ඉතින්. delivery එක කරලා මාස දෙක තුනක් යනකම් මෙහෙ රිදෙනවා. ඇයි දැන් මේ මෙච්චර කාල මෙහෙමනේ හිටියේ. පස්සේ දැන් delivery එක කරපුවා ආයෙ center of gravity එක අතන්ට එනවනේ. දොර healing වෙන්න ඕනේ. healing වෙද්දී අමාරුයි මේ පැත්ත ගොඩක් කල් නැමිලා ඉඳලා හින්දා. back pains එනවා. right? يعني spine එකේ pain එකක් එනවා. එහෙම තමයි. okay, that's it. 15 is done, no? 16. 15D4. 16. A motor vehicle goes in a horizontal circular path of, it should be radius R, as in the figure. Distance between two tires is 2D. The height up to the center of gravity from earth level is h. The maximum velocity without falling the car is. Okay. Okay, this is the car. 2D and h. Right. This is 2D and height up to center of gravity is h. Right? Listen. If distances are given, horizontal circular motion can be solved using force moments. Right? Theory class එකේ නම් කතා කරනවා. මේකෙන් paper class එකේ නම් මම හිතන්නේ මේ first time ගානක් එන්නේ නේ. Right? Without using F equals ma, is if distances are given, there is another way of solving the same using force moments. Right? So in such cases, first you have to identify the point of rotation. Right? Now let's say, look at the board. This is the first time I'm explaining a circular motion with force moments without using F equals ma. Say this point is point A, this point is point B. Right? First question. Tell me, what's the acting point of centrifugal force of an object? What's the acting point of centrifugal force? ඒක නම් මම explain කරා මොකක් හරි question එකක. What's the acting point of centrifugal force? What's the acting point? I'm asking for a general object, a general question, right? Not so this scenario. What's the acting point of centrifugal force? Huh? Sorry? Yeah, that's a direction, no? What's the acting point? Acting point of centrifugal force. Online? Quickly. Huh? Huh? Center. No. එතකොට ඒක අපි තුමු irregular shape එකක් වුණා. කොහොමද කියන්නේ? What's the acting point of centrifugal force? Huh? Center of gravity. ඕක මම question එක කිව්වා. Right? මම අර බස් එකක යන example එකක් කිව්වද කොහෙද? කිව්වනේ? ඒක. Right? Acting point of centrifugal force is center of gravity. So therefore, when this travels, centrifugal force acts away from the circle from the center of gravity, and centrifugal force can be written as mv squared over r. This is the equation of centrifugal force. Right? Now, due to this centrifugal force, tell me around which point this car is going to fall around, this car is going to topple if this force is exceeding the required limit. If you have watched supercar racing and everything also, you can have some kind of an idea, right? එක මතක් කරගන්න ඕනේ නැහැ. Just think about this and tell me about which point it is going to fall. It is going to rotate around if this force exceeds the exceeds a given value. B, it's B, right? It's B. මේ force එකෙන් දැන් මෙයාව rotate කරන්නේ. So it's going to rotate this way if it's going to fall. Right? So therefore, point of rotation is B. Right? So if it travels without falling, this is what it should satisfy. Right? Because if this force moment increases, it falls. Right? So therefore, if a car accident is happening due to higher speed at a bend, right? It happens always like this. If it topples away from the center like this, and if it goes away from the bend, it goes away from the bend towards this side, right? So හරිනම් මෙන්න මේ පැත්තේ audience එකට ඉන්න stage එකක් ගහන්න බෑ bend වල. මම ඒක කිව්වද නැද්ද? කිව්වනේ. මේ එහෙම incident එකකුත් ලංකාවේ වුණා. නුවරඑළියේ race එක. Right? තාම ගහනවා ඒ වුණාට. උනට ගහන්න බෑ අර නම්. ඒ පැත්ත තමයි සේෆ් සෝන් එකක් තියන්න ඕන. මේ කායක ඒ කියන්නේ දැන් රේසින් නේ. හිමින් බයිසිකල් පැදීම වගේ නෙමෙයිනේ. ඒකට ඉතින් හයිය යනවානේ. අනිවාර්යෙන් මේක බෙන්ඩ් එක ගියොත් යන්නේ මේ පැත්තට. ඒතර මේ පැත්ත ක්‍රවුඩ් එක ළඟ තියන්න ඕන නැහැ. ඉතින් අපේ කට්ටිය කරන්නේ ට්‍රැක් එක මෙහෙම නම් මෙහෙම බලන්නේ කාර් රේස්. ඇත්තටම වල්ලා දින මේ කටුකුරුන් දෙක තියෙන මේක හින්දා මේ ට්‍රැක් එක මෙහෙම නම් අර මොනවා හරි ලස්සන වීඩියෝස් ගන්න හරි මොනවා හරි එකට ට්‍රැක් එක යනවා කටාස්සරම. මේ මෙහෙම ගිහින් බලන්න ඇත්තටම කියන්නේ. කායයක් එළියට ආවොත් එහෙම සවලෙන් එකතු කරන්න වෙන්නේ ගෑනේ. ඉතින් අරගෙත් එහෙමයි උනේ. මිනිස්සු මරනවා 4ක් හරි 5ක් හරි එන ගානක් මරනවා. ඉතින් කායයක් නැවිලා වදින්නේ. හරි? that's the thing. තොර දැන්වත් ඉතින් මතක තියාගන්න මම මේ කලින් දවසත් කිව්වා I have explained this on a previous day even, right? So if you are watching a car race, right, on a track, right, don't stay away from the bend, right? Linear sides වලින් ඉඳලා අවුලක් නැහැ. දැන් සාමාන්‍ය track එකක් තියෙන මෙහෙම කියන්නකො, right? If this is the track, right? If this is the track, this is the track. These two areas are the most vulnerable areas. These two areas are the most risk in all areas, right? ඉන්න එපා ඉතින්. මේ පැත්තේ ඉඳන් බලන්න. මේ සේෆ්ම සයිඩ් එක තමයි මේ ඉන්සයිඩ් එක. බෙන්ඩ් එක ගන්නකොට. හරි? ඉන්සයිඩ් එකේ ඉතර සේෆ්. අවුලක් නැහැ. right? කායක ඉතින් මේ පැත්තෙන් බැලුවොත් මේ පැත්තෙන් බැලුවොත් ඉතින් වෙනසක් නැහැ නේද? සිමෙට්‍රික් නේ අනිත් පැත්තෙන් බලන්න. දැනගෙන මොකද මේ අපේ ඔඩියන්ස් එක මේ හැමතැනම ඉන්නවා මම දැකලා තියෙනවා. ඇක්සිඩන්ට් එකක් වුණොත් ඉවරයි ඉතින්. අර නෝරෙලි කේස් එක හොයලා බලන්න. ඒකේ වීඩියෝස් එහෙමත් තියෙනවා. වඩ 3ක් 4ක් විතර කරකිලා ඒ කායක එළියට පයින්. මිනිස්සු නිකන් පොඩි වෙලා යනවා. වාන්නෝ හොයලා. මට රයිඩර්ගේ නේම් එක මතක නෑ. එහෙම ඉන්සිඩන්ට් එකක් වුණා. අවුරුදු දැන් මම හිතන්නේ 3ක් විතර ඇවි. නේ? මතකද? ඔව් 3 years වගේ මේ හොයලා okay. Right. Now if there is safely driving on the bend without falling, this is what it should satisfy. Right? mg acts from the center of gravity downwards. Right? When leftward force moment is due to mg, that force moment is mg times d. Should be greater than or equal to, right? Clockwise force moment is due to mv squared over r centrifugal force. This height from the ground is h, right? You need v, subject v, right? V squared equals mgd over, sorry, m cancels, then gdr over h, right? So v is root gdr over h, right? This should be greater than or, sorry, less than or equal to this value, less than or equal to this value, right? Then the maximum safe speed is the equal case, no? Less than or equal, no? Then maximum safe speed is root gdr over h, dgr over h. 2 එකේ තියෙනවා 16 answer 2. Right? Okay, write this down with the question with a red pen. With a red pen, write down. Force moments about possible rotating point. Possible rotating point should be equal not to topple around, right? දැකලා නැත්නම් වීඩියෝස් හරි බලන්න ඕන තරම් තියෙනවා. බයික් රේසස් වලත් ඕන තරම් තියෙනවා. දැකලා දිනනවා. මේකේ එහෙම තියෙනවා මේ මොකද්ද F1 එකේ ගිය පාරත් ඒ වගේ හොඳ ඇක්සිඩන්ට් එකක් වුණා. මොකද්ද මන්ද ඒ බයික් එක R1 එකක් හරි මොකක් හරි. මම හිතන්නේ දැක්කද දන්නේ නැහැ. කවුද ඒකේ ඉන්න අර මේ පොපියුලර් රයිඩර් ස්පෝර්ට්ස් වල නේද ආවනේ. කවුද? බලන්නද? මට දැන් නම මතක නැහැ. මයිකල් සම්තිං නේ. ආර් මේ F1 රයිඩර් කෙනෙක්. මොකද නෝ? මොකද? F1 කියන කාර්යද වෙන වැරදුනා. නෑ F ෆෝමියුලා. මොකද්ද අර රේසින් එකේ? ෆෝමියුලා නෙමෙයි. රේස් එකේ නම් මතකත් නෑ. F1 නෙමෙයිද? මම පස්සේ බලලා කියන්න. හරි කොහොම හරි මේ MotoGP. ඔව් F1 කියන්නේ ෆෝමියුලා 1 නෙමෙයි. යා MotoGP. yes. මේ MotoGP එකේ ගිය පාරත් එහෙම කේස් එකක් වුණා හරිද? MotoGP එකේ ගිය පාර කියන්නේ 23 වෙන්න ඕනේ 24 නෙමෙයි. right? එහෙම කේස් එකක් වුණා. I think it's R1 හරි මොකක් හරි. හරිද? ඒ වගේ බයික් එකක්. මොකද මේ හරියෙන් බෙන්ඩ් එකෙන් පයින්නවා. පැනලා මේක පෙරලිලා බයික් එක පෙරලෙනවා. රයිඩර් විසික් කරනවා. බයික් එක පෙරලෙනවා සාමාන්‍ය වඩ 10ක් විතර. පෙරලා බයික් එක යනවා මීටර් 500 ගණක් විතර එහා පැත්තට ඇදිලා. ඒක මේ ප්‍රැක්ටිස් එකක් ඔඩියන්ස් එක කවුරුත් නැහැ. අනිත් එක කොහොමත් මේගොල්ලන්ගේ මේ පැත්තේ ඉඩ දීලා දෙනවා. හොඳට බලන්නකෝ පිටරට රේස් එක දැකලා තියෙනවා. බෙන්ඩ් එකේ මේ පැත්තේ මේ සෑන්ඩ් සෝන් එකක් තියෙන්නේ. සෑන්ඩ් දාන්නේ ඒකයි. To absorb that velocity and take it to a rest in a quick time. අපේ මොනවද කරන්නේ? අපේ එහෙම දාන්නේ පැන්නොත් ඉහරයි ඇත්තනද? ඩට් ටිකේ වදින්න කායක පැන්නේ. අපේ මිනිස්සු ඒ තරම් ළඟ ඉන්නේ. ඇත්තම කියන්නේ. මෙච්චර කිව්වත් වැඩක් නැහැ කතා කරලා. දැන් මේ වගේ මෙහෙම සෝන් එකක් තියලා මෙහෙ තමයි මිනිස්සු ඉන්නේ. ඒතර මේ සෝන් එක ඇතුළේ මෙයා රෙස්ට් එකට යනවා. දැන් මේ බයික් එක පන්නකොට around 300 විතර මෙයාගේ ස්පීඩ් එක මං හිතන්නේ. ස්පීඩ් එක පෙන්නනවා. නම්බර්ස් මතක නැහැ. 300 වගේ ස්පීඩ් එකේ බයික් එක පයින්නේ. ඉතින් ඒක මීටර් 500ක් ගිහලා ස්ලෝ වෙනවා නම් හොඳයි. 300 වගේ ස්පීඩ් එකක. මේ CT 100 එකක් එහෙම 60ට ඇද්දියක් වුණත් මීටර් 500ක් විතර යනවා. ඉතින් ඒක තමයි කියන්නේ අර සෑන්ඩලින් එක කරනවා. එක්ස්ප්‍රස් වේස් වලත් ඔය සෑන්ඩ් එක තියෙනවා. අපේ නෑ. ඒ කියන්නේ අර මේ heavy vehicle lanes වල in expressways safe lanes තියෙනවා filled with sand. අදිස්සියාරි මොකක් හරි brake failure එකක් ආවොත් ඒ sand තියෙන lane එකට දාගන්න පුළුවන්. දාපු ගමන් ඒක slow වෙනවා. අපේ එකයි මේ එහෙම නැති හින්දා ඔය accidents එහෙම brake failures වලින් ගොඩක් වෙනවනේ. තියෙනවා ඉතින් safety options they exist in the world but not here yet. Right? Okay. May there one? 17. Sorry, 17. Yeah, 17. That is an easier one. Dimensions, units, dimensions. The position x of a particle at a time is given by x equals v naught over a. Yeah, x equals v naught over a times 1 minus e to the power minus 80. 1 minus e to the power minus 80. Where v naught is constant and a is greater than 0. The dimensions of v and a are. Right, dimensions of v and a. Okay, what is e here? What is e in this equation? Right, so in physics also we have this simple e, right? That is in unit 11. But if you are doing combined math, you should know this. What is this? Exponential function, right? This is exponential function and this is a constant, right? So just know that this is a constant. Exponential function. Indices are dimensionless. Right? So therefore, this is the index 80. Right? First argument is dimensions of 80 should be dimensionless 1. Right? Then a times t is time equals 1. So dimensions of a is t minus 1. So 1 is here. Dimensions of a is t minus 1. Right? And we know terms with same dimensions only can be added or subtracted, right? Units with terms with same dimensions can only be added or subtracted, right? This is a subtraction. 1 minus something, no? 1 is dimensionless, right? Which means this whole term is also dimensionless. Then as a bracket, this whole bracket is also dimensionless. This bracket is also dimensionless, which means total dimension of x in left hand side depends on the dimension on right hand side, that is only v naught tau a, because this part is dimensionless, right? X is given, right? Displacement, no? Position. Yeah, position means there's a displacement. X is a displacement, that is L. We need v naught and a is known t, so which means v naught is lt. Answers are lt and t minus 1. v naught and L, lt and t minus 1. Correct the first answer as lt and t minus 1. So 17, answer 1, lt and t minus 1. This is not t, right? This is t minus 1. Again t minus 1. Then it comes lt minus 1. Hari first answer again. Alright? T no? That is lt minus 1. Answer 1. So 17, 1. Right, next. 18. In which one of the following does quantity x have the same dimension as quantity y? Right? If you have known equations, you can argue using the equation as well. If not, you can check dimensions. Right? Known equations equations right? Momentum over wavelength. Divisions and multiplications ඔක්කොම තියෙන්නේ. දෙකක් තුනක් check කරද්දී අනිවාර්යෙන්ම ඔව අහුවෙනවා. Right? මේකම check කරන්න ඕනේ. If you check the division of momentum and wavelength, it is applicable for coming 3 questions. ඒ වගේ හොයන්න පුළුවන්. Momentum over wavelength. See? For the first one, I'm just checking momentum mv over wavelength. Right? Momentum is mlt minus 1 over wavelength is L. So what comes is mt minus 1. Right? mt minus 1. Energy over frequency. Energy over frequency. Wanna check කරලා බලන්න. Energy over frequency. Energy is, dimensions of energy is ml squared t minus 2 over dimensions of frequency is t minus 1. Right? Then this becomes ml squared t minus 1 when comes to the row. Right? Multiplications දෙකක් check කරා නම් කෙලින්ම answer එක මොකක්ද කියලා හොයාගන්න පුළුවන්. දන්න equations ඔතන තියෙනවා. මම පස්සේ කියන මොනවද කියලා. එහෙම දන්නවා නම් ඒවෙන් check කරන්න පුළුවන්. හොඳයි. දැන් මේකේ ඕන multiplication එකක් check කරන්න. mv times lambda. mv times lambda. Right? mv is ml t minus 1 into lambda is L. Right? ml squared t minus 1. ඒක මෙතන ඇවිල්ලා තියෙනවනේ. එතකොට answer එක තේරෙනවද? Then momentum into wavelength equals energy over frequency. 2 ne? 2 ne? Right. For 18, it's 2. What are the known equations? Known equation එකක් මෙතන තියෙනවා. What are the known equations? E equals hf. මේක දන්නවා? In physics, you are seeing this equation in unit 11. මේක matter and additional equation එකක්. If you are doing ICT, you know this as E equals h nu. E equals h nu දන්නවනේ? ICT නෙමෙයි chemistry. Right? දන්නවනේ h nu කියන එක දන්නවනේ? ඒකම තමයි මේ තියෙන්නේ. nu කියන එක physics වල අපි ලියන්නේ නැහැ. nu පොඩ්ඩක් obsolete ඒකයි. හරි. දන්නවනේ physics වල අපි update වෙලා ඉන්නේ. chemistry වගේ නෙමෙයි. nu ලියුවේ ඉස්සර. අපි update හරි. මේ දැන් ගොඩක් කල් ඉඳන් මේ f විතරයි ලියන්නේ physics වල හරිද? E equals hf. ඉතින් මේ hf කියන එකෙන් එන්නේ මේක. එතකොට මේ මෙතන E of f අහලා තිබ්බනේ මේ. E of f කියන්නේ අපි non quantity එකක්. ඊට මේ අනිත් equation එකත් known එකක්. Have you heard about wave particle duality and de Broglie wavelength? දන්නවනේ? ICT වලදී de Broglie wavelength කියන එක අහලා තියෙනවා නම් ඒ equation එකත් මෙතන තියෙනවා. What is the equation of de Broglie wavelength? That also we have in unit 11. මේ ඔක්කොම අපිට තියෙන equations. Dimensions check කරන්න දීලා තිබ්බට. de Broglie wavelength lambda equals h over mu. Right? mu නැත්තම් මේක p කියලා ලියන්න පුළුවන්. Momentum. Right? නේ? එතකොට මෙතන අහලා තියෙන්නේ මොකද්ද? Momentum times lambda and මෙන්න මෙයාගෙන් යාර මේ දෙකෙන්ම h එන්නේ. පේනවද? මම එක කිව්වේ if you have known equations you can get it just by using equations. Right? මේක h එක subject කරොත් එන්නේ lambda into mu. නේ? ඒක තමයි මේ තියෙන්නේ. If h is subjected from here e of f ඒක තමයි මේ තියෙන්නේ. These are the dimensions of Planck's constant. Dimensions of Planck's constant. Planck's දන්නේ? Planck දන්නේ? Unit 11 එක කරද්දී Planck දන්නේ නැති වුණොත් තමයි case එක වෙන්නේ ඔය. Okay, that's it. 19. 19 කියන්නේ තායිමත් easy. What's the answer? Huh? 19. 1. 1ද? 19 කියන්නේ මේ දැනට තියෙන ලේසිම question එක මං හිතන්නේ. Online students, any answers? Question 19. A, B, C, D. 2AB. 3BC. මේ values එහෙම වැරදි නම් directions වැරදි නම් කියන්න 3BC 2CD CA DA. Right. So start from anywhere that is referred to you. Right. I'll be starting from here. See, if you are using additive law of vectors, directions of arrowheads and coefficients should be same. If you are using triangular law, directions of arrowheads and coefficients should be equal, and triangular law is only for two vectors and additive law is for any number of vectors having same direction and same coefficients. Right? Okay, see. Now I'll be starting from here. See, look at the board. I'll be starting from here. We know 3BC means BC plus 2BC, no? 3BC means BC plus 2BC, right? Now if I start from here, I can simplify 2AB and 2BC. I'm going to consider this one. Keeping this BC aside, I'm going to simplify with this 2AB and 2BC. What is the resultant of 2AB and 2BC? What is the resultant of 2AB and 2BC? ලියන්න ඕනේ නැහැ නේ. 2AC. තේරෙනවද? ලියන්න ඕනේ නැහැ, ලියන්න ඕනේද? 2AB, vector 2AB plus vector 2BC equals vector 2AC. Right? Now, these two are simplified. Look at the board. These two are simplified. And the resultant of these two is 2AC. Here we have been given a CA already. Then simplify this with this given CA. No need to write if you can understand. 2AC plus CA. This can be written as 2AC minus AC, no? So resultant is AC, right? Which means now this is already simplified. Look at my diagram. This is already simplified. It's gone, right? And this 2BC is also simplified. And only 1BC remains here. 1BC remains here, right? And this is also simplified. And here you have got an AC. You have got an AC. Right? Now these three are simplifiable. These three are simplifiable. We can start from here. vector AD plus vector AC plus vector CD, right? I'm going to take one CD, yeah? One CD. Simplify කරන්න පුළුවන්. See? Vector AD, sorry, DA. Vector DA. Don't write, I'm just writing this to show you the steps. Vector AD, sorry, vector DA plus vector AC plus one CD from here. Plus one CD from here. What's the resultant? Vector additive law. What's the resultant? Huh? If starting point and final point are same, 0. If starting point and final point of a vector diagram is same, this means 0, right? Which means DA is also simplified, AC is already simplified, and one CD is also simplified, right? Only these two remains. Only these two remains. The resultant of these two is from B to C to C to D. Resultant is BD. Resultant is BD. Answer 4. මේක නම් වරදින්න බෑ. මේක තමයි දැනට තිබ්බ ලේසිම question එක. Got it? BD. An object starts motion with an initial velocity u, travels with a uniform acceleration a. It displaces 40 meters in 4 seconds and 60 meters in 6 seconds. Okay. See, values of v and a. Considering the first scenario, I'm going to write an equation like this. Displacement during 4th second is given, right? So, how many seconds are spent before the 4th second? 3 seconds, right? Then, if I need to get the displacement during 4th second, right? If I find the total displacement up to 4 seconds, and if we subtract the displacement up to 3 seconds, right? That difference will be the displacement during the 3rd second, no? During the 4th second, no? That's the logic I'm going to use. See, then, see, S4, let's say, displacement up to 4 seconds, using S equals UD plus half AD squared, right? Then, up to 4 seconds means time is 4 seconds. Then u times 4 plus half a t squared 60. Right? Then S4 equals 4u plus 8a. Say equation 1. Right? Up to 3 seconds, S3 equals u times 3 plus half a times 9. Right? Then S3 equals 3u plus 9a over 2. 9a over 2, equation 2. 1 minus 2 is the displacement done during the 4th second. Right? That is 40 meters. It is given. Simplify this. 40 equals, මෙතනින් තමයි එක equation එකක් එන්නේ. 40 equals 4u minus 3u is u. Right? 8 is 16 over 2, no? 16 minus 9 is 7. Right? Then plus 7a over 2. I will consider this as equation A. Then equation now. Do the same for the other second given. 6 second. 6 second එකටත් මේ වැඩේම කරන්න. තව equation එකක් එනවා. ඒ දෙක simultaneous. ඒ දෙක simplify කරා නම් answer එක. Right? Next one, up to during 6 seconds means up to 6 seconds and up to 5th second, right? S6 up to 6 seconds. 6 second you can deduce if you are comfortable with, right? The measuring in a pattern you can see the pattern how the answer coming, right? So if needed you can deduce. See, I'm going to deduce. If there is up to 6 seconds, this is 6u, right? Plus half a into 36, no? Without simplifying, keep it like this. S5 equals 5u plus half a 25, no? Right? Subtract these two. Say this is 3 and this is 4. 3 minus 4. 3 minus 4 is 60 meters. 60 equals 6u minus 5u is u again. And 36 minus 25 means 11. Then 11a over 2. Say equation D. See, two equations with two unknown variables. Simplify these two as two simultaneous equations. Right? Simplify and tell me what u and a is. A equals 10. 10. U equals 5. Check whether a equals 10 and u equals 5. Simplify. Same. What about online? What are the answers for A and U? Answers for A and U. Same. A equals 10 and U equals 5. Yeah, I think it's correct. Simplify and see. A equals 10 and U equals 5. Answers of U and A. U and A means 5 and 10. 4. For 20, answer 4. For 20, answer 4. Right? Okay, go to part 2. Question 1. A part 1. A part A actually. Right. Is clear? First one, part A. A balloon is moving upwards with 15 ms minus 1 uniform vertical velocity. Right? Okay. A balloon is moving upwards. A balloon is moving upwards with 15 ms minus 1 vertical velocity. Right? A stone is freely released from the balloon at a point 200 meters above the ground. Right? So I have explained you this logic. If a sub-object, a sister body, sister particle is released from a parent body, it immediately acquires the direction and magnitude of the velocity of the parent body. Right? Calling questions same thing. Same thing. Make a field release because balloon is moving with 15 ms minus 1. Right? So therefore, once this stone is released, see, I'll be drawing the stone somewhere here. Once this stone is released, immediately it acquires this 15 ms minus 1 from its parent body. So therefore, now it released 200 meters above the ground. It is released 200 meters above the ground. Right? So with this velocity, it will go up and reach the maximum point and then only it comes back. This is the motion. Right? Otherwise, it is not going to be a downward motion at once. Right? At the same moment, a separate stone is thrown vertically upward with 15 ms minus 1 vertical velocity. Okay, at the same time, now if this is t equals 0, now at the same time, another stone is thrown vertically upwards on the ground at the same time, t equals 0. Right? So it will also go up and reach its maximum point and it should come back. This is the motion of the second particle, second stone, not the particle, second stone. Right? Okay, now this is the first stone. This is the first stone of our story, and this is the second stone of the story. Right. Okay, first one. A, as seen by a man on ground. A part 1. See, A part 1. As seen by a man on ground. What's the velocity of the first stone? Tell me. As seen by a man on ground. Does that person see this 15 ms minus 1? A person on ground. Can that person see the moving balloon with 15 ms minus 1? No. Yes. Balloon. If a person is on ground, listen. Now a person is observing the balloon from the ground, right? And balloon is moving upwards, right? So it's clearly visible that balloon is moving upwards for the person on the ground, right? And if the stone is thrown, then stone immediately acquires a velocity of 15 ms minus 1. Then it is also visible to the person on the ground. 15 velocity it goes up now. It is visible, right? So therefore, what that person sees is an upward 15 ms minus 1. Direction no. Value is also asked. Upward 15 ms minus 1. Velocity of the second stone, that is also same. That is anywhere on the ground. That is also upwards 15 ms minus 1. Right? Now, if a person in the balloon sees this, then he won't see this velocity. Yeah? See, now the part which is not asked in the question is this. As seen by a man on balloon, in balloon. This is not asked. See? As seen by a man in balloon. Now, balloon is also moving upwards with 15, and initial velocity of the stone is also 15. So, therefore, he don't see any relative motion with respect to the balloon of this ball, of this stone, right? So, therefore, this person doesn't see any velocity of the stone. With respect to the person in the balloon, there is rest, but with respect to the person on ground, that is 50, right? Relative velocity. Part B. Part B. What is the time taken by first stone to reach ground? Right. That is starting from here. No? Then apply S equals ut plus half d squared downwards. Right. S from here to here is 200. U is upwards. I'm using the equation downwards. So that is minus 15. Minus 15t. Right. May minus එක ලියුව නැත්නම් එතනින්ම ගාන ඉවරයි. Right. Plus half g is 5 no? 5 t squared. Right. This equation is divisible by 5. 40 equals minus 3d plus t squared. Now the quadratic equation is t squared minus 3d minus 40 equals 0. Find roots of the equation. Find roots of the equation. 3 and 40. 8 times 5, right? 8 times 5. Then minus 8, t minus 8, t minus 8 and t plus 5. T minus 8 and t plus 5. Right? So from here, it is going to be contradictory as it's a negative value. Right? So therefore, t should be 8 seconds. 8 seconds. Right? Part C. You got 8? 8 hours. Part C. What is the time taken by second stone to reach ground? Okay. Then apply S equals ud plus half d squared upwards for the second stone. Right? S from starting point to the final point is 0. U is 15. Then 15t minus half g means minus 5. Minus 5d squared. 1t to t cancels. 5t equals 15. T equals 3 seconds. Is it 3? 3 seconds. D. What is the time difference between above B and C? Very easy. Right? Time difference is 8 minus 3, 5 seconds. Part B. Part B. How many strings are here? How many strings are here in the given question? Read the question carefully and tell me. How many strings are here? 12 newtons, 15 newtons, theta ACB, ACB, and this angle is given theta. Yeah, how many strings? 2, right? Only 2. There are only 2 strings. The string AB is fixed on a vertical strand and a pulley, as shown in the diagram, of 15 newtons and 12 newtons weights are suspended at B and C respectively, right? Then only 2 strings, right? Now, even though this is the same string, listen, even though this is the same string from A to B, if there is another string, a different string connected somewhere in the middle, tension at either sides of the same string are going to be different, right? Same string again, tension same. If there is no any connections in between, then connection nothing, you know, so therefore it's going to be different. So I'll label these tensions this way. Say this side is T1, right? If there is T1, this is also T1, this is also T1, this is also T1, right? If the other side is T2, this is also T2, right? And this is a separate one, say T3 and T3. That's it, right? We need calculate the tension of the string of AC segment, this one, T2, and inclination theta, right? So write these equilibriums. First one, vertical equilibrium of 15 newtons. Very straightforward. Vertical equilibrium of 15 newtons. T1 equals 15. T1 equals 15. Right? Then vertical equilibrium of 12 newtons. See? This is an equilibrium. Vertical equilibrium of 12 newtons. Vertically upwards you have T3. T3 equals 12 newtons. Right? And now point C is also an equilibrium. It's an equilibrium. Then for this side, that is T2 sine theta, and this direction, that is T2 cos theta. These are the components, right? Then I'm going to consider the vertical equilibrium of C. Vertical equilibrium of point C, yeah? Point C, or you can say joint C, right? Point O joint. Vertical equilibrium of point C. Vertically upwards, we have T2 sine theta. T2 sine theta, right? Equals vertical downwards T3. Vertical downwards T3. T3 is known, which means T2 sine theta equals 12. I'll label this as equation 1, right? Then horizontal equilibrium, HE, horizontal equilibrium of point C. Horizontal equilibrium of point C, horizontally rightwards T2 cos theta. T2 cos theta equals T1. T1 is known, which means T2 cos theta equals T1. T1 is 50. Equation 2. Right. So it says calculate the tension at AC segment and the inclination. Now, in essay questions, you have to follow the same order of the questions, right? So which means before finding the inclination, you have to find the tension. Before finding the inclination, you have to find the tension. සමහරලාට ඔය දෙක මාරු කරලා තිබ්බොත් ලකුණු දෙනවා. Separate questions වලත් නම් කොහොමද දෙන්නේ නැහැ. දැන් මේක single question එකේ ඉඳන් සමහරලාට මාරුනොත් දෙනවා. But the exact correct way is that ඕනේ order එකට තමයි අහලා තියෙන්නේ. මුලින් ඕනේ tension එක. How to find tension by removing theta. මොකද්ද කරන්න තියෙන option එක? හදන්න පුළුවන්. හා? divide කරොත් T2 නේ cancel වෙන්නේ. We need T2 now. හරි විනාය. මොකද option එක? මේ එක option එකේ තියෙන්නේ. If you need to remove a sine and a cos term, sine cos remove කරන්න එකම එක විදියයි තියෙන්නේ. එකයි තියෙන්නේ. මොකද්ද? tan නේ. tan කියලා sine cos remove කරන්න tan වලින් බෑ ඉතින්. theta තියෙනවනේ. කොහොමද කරන්නේ? Once you are doing maths. අන්න හරි. අන්ත එකෙක් කර හිටිය පන්තිය බේරගන්න. වෙන කිසිම ක්‍රමයක් නැහැ හොඳේ. If you need to remove a sine and cos equation, subject sin theta and cos theta from these two and consider the square because sin square theta plus cos square theta equals 1. චරමයි කරන්න තියෙන්නේ වෙන මොකුත් කරන්න බෑ. Right? Okay. See? Sin square theta plus cos square theta equals 1. Then from here sin theta is 12 over t2. Right? Then this is 144 over t2 squared plus cos theta is 15. 15 squared is 225 over t2 squared equals 1. Right? t2 squared is common. I'm multiplying the whole equation by t2 squared. Then 144 plus 225 equals t2 squared. Right? What's the value here? 44. 369. Huh? Correct? 369 equals t2 squared. Check values. t2 is root 369. මෙන්න මේ value එක හොයාගන්න ඕන. 400. අර value එක හොයාගන්න ඕනේ. That's the only way of removing sin theta and cos theta. Right? Divide කරලා බෑ. ඒක හොයන්න ඕන නම් ස්ක්වයර් කරන්න ඕන. හරිනේ? $19.20 newtons. Right? Now then if you need the angle, divide these two. Right? 1 over 2. 1 over 2 is sin theta over cos theta. T2 cancels. Sin theta over cos theta equals 12 over 15 tan theta. Sin over cos is tan. That is 12 over 15. 12 over 15 means 3 times 4 over 5. Then theta equals tan inverse මේක වන්නත් ඕනේ 0.8. tan inverse 0.8. එවද? essay questions වල අනිවාර්යෙන් හොයන්න වෙනවා. tan inverse 0.8. පරක් වෙලානේ මට අමතක වුණා. ඔයාලට අමතක වුණාද? නෑ. මේ 9:25. ඒ ඩ්‍රයිවර්ගේ හරි කන්ඩක්ටර්ගේ හරි නම්බර් එක එහෙම නැද්ද? නෑ. මාරු වෙන්නේ නෑනේ මේ බස් එකේ ගොඩක් දාට ඉස්සර නම් එකම එක්කෙනා හිටියේ. මාත්‍රෝ ගිහිල්ලා දෙනවා. මාරු? ඉස්සර ඩ්‍රයිවර් නම් මාරුනේම නෑ කන්ඩක්ටර් මාරුණා. මොකද බස් එක ගිහිල්ලා පාක් කරන්නේ කරන්දනනේ. බස් එක පාක් කරන්නේ කරන්දන පැත්තේ නේද ආව? බස් එක පාක් කරන්නේ තාම කරන්දන පැත්තේ නේද? ඒක තමයි. එතකොට මේ පැත්තේ ඩ්‍රයිවර් කෙනෙක් ඉස්සර හිටියේ. එයා හින්දා මාරුන්නේ නෑ. Go safe. 39 answer එක අමතක වුණා. 38 degrees 39 minutes. 38 degrees and 39 minutes. Final answer. Part C. Take it down quickly. Just know this. This is the only way possible if you need to remove sin and cos terms. If you need to remove. Right? වෙන මොකුත් නැහැ maths වල. වෙන කිසිම විදියක් නැහැ maths වල sin and cos term එකක් remove කරන්න. මේක විතරයි තියෙන්නේ. Very straightforward. Right? Part C. Right, I'll be erasing this part C. Okay, see, a 70 kilogram mass of man stands on a balance which is fixed in an elevator that is moving vertically upward direction. Again, an elevator question, right? Right. Now this person is standing on the elevator on a pan balance like this, right? Something like this, right? This is moving upwards. This is moving upwards. 70 kilogram. So his weight is 700 newtons. Moving vertically upward direction. The elevator starts its motion with rest and 3 seconds time period with 4 ms minus 2. Right? Acceleration. Finally, it becomes rest with uniform retardation. Weight of the man was indicated as 490 newtons when it is moving with the retardation. Right. First one. First part. Calculate the apparent weight of the man when the elevator is moving with an acceleration. Apparent weight is the reading of the pan balance. Right? Apparent weight is the reading of the pan balance. Reading of the pan balance is equivalent to the reaction on this person. Right? So apply F equals ma upwards. Very straightforward. R minus 700 equals 70 into given acceleration is 4. Right? Then R minus 700 equals 280. So R equals 980 newtons. First one 980. Right? Second one, find the displacement moving with acceleration. Apply a linear motion equation. Right? We'll do here. Apply a linear motion equation. Time is known, no? S equals ut plus half a d square. Time is known, right? For 3 seconds, no? Right. Then S equals u is 0, half, acceleration is 4, 3 seconds, 9. 18 meters. Third one, find the maximum velocity obtained by the elevator. Now, if there is a motion with an acceleration and a deceleration, maximum velocity should be at the last point of acceleration. No? That's the logic, right? If there is a motion just with an acceleration, a uniform acceleration, and a straight retardation, then maximum velocity is at the last point, the final point of acceleration, right? That's the argument. Then maximum velocity is at this last point of the acceleration. Apply v equals u plus ad up to that point, up to how many seconds? 3 seconds. Then Vmax equals, say Vmax, u is 0, plus a is 4, t is 3, 12 ms minus 1. Part 4. Find the value of retardation of the elevator. Right. Now, a data is given, a hint is given. When it moves with the retardation, this R has been indicated as 490. Right? See, now, if this system retardates in this direction, which means it accelerates in the downward direction. No? Right? Considering that, I am going to use F equals ma downwards. Then we can write these forces as 700 minus nu R, say R dash. Right? Then that is 700 minus R dash. And R dash is given. R dash is 490 now. Say R dash, that is given 70 times retardation A. But R dash is given as 490. Right? Then 700 minus 490 equals 70A. What's the value? 210. Right? 210 equals 70A. So A equals 3 ms minus 2. Now, since I applied the equation downwards, I am getting it as 3. It's asked as retardation, no? So therefore, no need to, not a must to write the minus sign because it's asked as a retardation. Right? Retardation value, it's 3 ms minus 2. Right? So even if you write it as 3 or minus 3, both are fine. 5. Find the displacement moved with uniform retardation. Displacement with the retardation. Since velocity is known, time is unknown, right? I'm going to use this one. V squared equals u squared plus 2as in the moving direction upwards. Finally, it is coming to the rest, 0. And u is the starting point of retardation. It is at 12. 12 squared plus 2. But a is a retardation in upward direction, minus 3 s, right? Minus 3 times 2 is minus 6. So this is 6s equals, don't simplify, 12 times 12, right? 144 ke liya nepa meka cancel වෙනවනේ. 6 times 2. So s equals 24 meters. Right? Okay. Second one. Take it down quickly. Listen while writing මේ වාර මේ ළමයි කාලා දෙන question එකක් මම මේ කියන්නම් මේක ඕගොල්ලන්ටත් ගන්න දෙයක් තියෙන හින්දා මට මේකට answer එක දෙන්න මේක ඕගොල්ලෝ දන්නවා මේ මම මේ තියෙන එක කියවන්නේ right I'm just reading out what is being sent. As we have learned that there are 3 types of frictional forces in O levels: static friction, limiting friction and dynamic friction, but we are learning only 2 frictional forces in A levels: limiting friction, limiting static friction and dynamic or kinetic friction. Is there any difference between these කියලා අහලා දෙනවා. මොකද කියන්නේ? ඉතින් ඔයගොල්ලෝ වැච්ච එක ළමයි මොනවද? What's the answer? මොකද කියන්නේ? වැඩි තේරෙන්න ඕනේ. Limiting friction is also a static friction. So therefore, there are only 2 types of frictional forces: static and dynamic. Limiting friction is the maximum static friction. It's called the limiting friction. So therefore, static friction is also, limiting friction is also a static friction. තුනක් නෑ. There are only 2 types. Limiting friction is a special point we have in a static region, in the static region. That's the last point of a static region. Right? That's the thing. ඇයි ඔලවල්ස් වල එහෙම කියනවද? තුනක් කියලා? For the first time I'm hearing this. කියන්නේ මෙහෙම ඔලවල්ස් වල එහෙම 3 types කියලා කියන්න නම් විදියක් නෑ. මං හිතන්නේ මොකක් හරි පැටලිලා ඇති. There are only 2 types. Limiting friction is a part of, that's the last point of static friction. Right? That's the thing. Okay, second one. Second one. Boat services are there on the waters where the tourism activities are done for the entertainment of tourists. There are tubes filled with air hang around the boats. මේ question එක කලින් paper එකේ තිබ්බද? ඕගොල්ලන් කලින් paper එකේ තිබ්බද? Okay. Sure තිබෙන්නේ නැන්නේ. ඔය මම ඕක එක paper class එකක දැම්ම 25 එකේද 26 එකේද කියලා මතක නැහැ. තිබෙන්නේ නැන්නේ. ඔයගොල්ලෝ තිබෙන්නේ නැහැ. එහෙනම් 25 එකේ තිබ්බ ගාන. Sure නේ? තිබෙන්නේ නැහැ. බෝඩ් එක මෙහෙම තිබ්බනම් මතකනේ question එක. Right. Okay. 25 paper class එකේ එහෙනම් paper එක මේක තියෙන්න ඇති මේ ඔයගලගේ paper එකේ තාම නෑ හරි දැන් මේකෙන් පස්සේ ආයෙත් නෙත් නෑ ඉතින් තිබ්බද කියලා මම අර වෙලේ මට question එක මතකයි right boat services are there on the waters where the tourism activities are done for the entertainment of tourists. There are tubes filled with air hang around the boats. The engine is fixed at the back, generates the power to move the paddle by burning fuels. The mass of a boat without passengers is 600, which means empty boat is 600, right? 600 kilograms. 8 people of each weight 70 kilograms can be loaded maximum. The air-filled tubes immense. It should be immerse, not immense. Immerse. Immense, immerse. Immerse. Air-filled tubes immerse in water to provide the ability to load additional people on the boat. The paddles attached to the engine of the boat push the water backward and obtain the force to move the boat boat forward. An extra work should be done when the paddles are rotated to push the water due to hydrostatic pressure. The effective area of the paddles is 0.05 square meters. Density of water is 1000. Right. Second one. What are the requirements to be fulfilled to float the boat on water? Yeah. What are the requirements? That's a very straightforward theory. Float the boat. That is called law of flotation. There are two requirements. First one, weight equals upthrust. Second one, there are two requirements in law of flotation. Anything which floats freely follows law of flotation, right? In hydrostatics, you have two main theories. Two main principles actually. One is Archimedes principle. The other one is law of flotation. These two are different. No? Those two are different. Law of flotation and Archimedes principle. Second one? Yes, that one. Center of gravity and center of buoyancy should be on the same vertical line. Those are the two requirements, right? First requirement is upthrust equals weight. Don't write U equals mg in labels, right? You have to write it in words. Conditions asked. Write in words. Write down upthrust. Act on board equals. Write in words. After writing in words, you can mention it in symbols if needed. Upthrust act on board equals weight of boat. Upthrust act on board equals weight of boat. Within brackets write down U equals mg. Second condition, center of gravity and center of buoyancy. Center of gravity and center of buoyancy should be on the same vertical line. Center of gravity and center of buoyancy should be on the same vertical line. Right? Two conditions. Very straightforward. This is the theory part. Law of flotation. Right? Law of flotation. These two conditions are coming out from law of flotation. Right? Second one. Sketch the forces acting on empty boat. Right. Then copy it down and sketch. Essay එකක් නේ තේරෙනවනේ. ඕක ඇන්දොත් හොඳයි ලස්සනයි බෝට් එකක්. ඒ වුණාට ඉතින් ඕක ඇටච් කරන්න බෑනේ. In an exam. Right? එහෙම අයත් ඉන්නවද? ඒ කියන්නේ exam තියෙන අර exam vibe එකේ මේකම මාක් කරනවා. ඒතර ඉතින් වැඩක් නැහැ නේද මේක ඇටච් කරන්න නැහැ. Right? Copy it down. ලස්සන එකක් අදින්න ඕනේ නැහැ. Just copy down a sketch of the boat. And mark forces. MGN, upthrust, and if these two are not acting on the same line, no marks are given. Right? එහෙම අදින්න බෑ. දැන් ඒක condition එක මෙතන කියලාත් ඉවරයි ඔය. මේ දෙක හරියටම same line එකේ තියෙන්න ඕනේ. If you have marked these two forces in two different lines, no marks are given for the diagram. No marks at all. Right? ඒක හරියට තියෙන්න ඕනේ. Find the upthrust on the boat when 8 people are on it. Since volumes are unknown, we can find the upthrust as U equals mg. Right? When 8 people are on it, no. Then as total mass 600 is with the empty boat, 8 people means 70 into 8 into g. Right? 550, 11,600 newtons, right? 11,600. 4. 4 part A. Find the minimum force to start the motion if there is an extra resistive force of 0.6 newtons per kilogram on the board. Check the unit. Newtons per kilogram, right? Then total resistance is, see, then total resistance is, now if there is 0.6 per 1 kilogram, right? Here we have this much of kilograms, 1160 kilograms, right? Multiply this. For 1 kilogram, it's 0.6. Then for this much of kilograms, 0.6 into this number. What's that? 690. 690. 96. 696. 696 newtons. B. Find the speed of the water pushed back to obtain the minimum force above. About that equation I explained and I proved that equation in a previous paper, right? If you need to find the force due to momentum change of a fluid, right? The equation is prove F equals rho a v squared. Prove F equals rho a v squared, right? This is a direct equation you can use. A direct equation you can use the equation. Now the minimum force required is 696 to start motion. This is 1000. Area is given. So 0.05. 0.05 v squared. Simplify v from here, right? Then v squared equals, now from here 50 comes, right? Yeah, 50. Then this is 696 over 50, right? This is divisible by 2. 696 means 348 over 25, right? Make a root take 1, 348, it's a multiply of 4, right? The multiply of 4. 4 times 87. Is it? 4 times 87. So this is 4 times 87 over 25. V equals square root here is 2 over 5 into root 87. Make a simplify karana. This is an essay question, right? What's the answer? Is it 3.73? 3.73. 3.73 ms minus 1. Next one. 5. Find the rate of work done by pedals. Rate of work. Tell me a single term for rate of work done. Rate of work done. A single term for rate of work done. Power. Rate of work done. Rate of energy done. Power. So we know P equals FV. Very straightforward. Power equals FV. Force is 696. And velocity is 3.73. What's that? This is part A. Part B. What's the value here? $2,590, 97.60. If there is not 0, 60 watts. Next one. If the efficiency of the engine is 40%, find the energy that should be given to it during a unit time. Energy during a unit time is again power. Energy during a unit time is energy over time. No? So it's again about power, right? Efficiency of the engine is 40%. Then tell me Is this the output power of the boat or input power of the boat? What is this? Input to output? Huh? No, this is the output, because now boat actually travels with this velocity under this force. It actually travels. So this is not the given force. This is not the given power. This is the output power. Correct? This output is 40% now. And what you are asked to find is the input. Find the energy that should be given. Input energy should be given is the input. So this is the output. That is the first thing you need to understand, because this is the actual velocity of boat under this condition. So this is the output power, right? What is efficiency as an equation? What is efficiency as an equation? Efficiency as an equation. I think I have told this. I have explained this. Efficiency is output to input to input to output. Efficiency. What is the equation of efficiency? Output to input, right? Into 100%. Output over input. This is the general equation of efficiency. 100%, right? It can be any output of any input. Maybe energies, work done, or currents, anything, voltages, efficiency in terms of anything. This is a general equation, right? And in reality, 100% efficiency cannot be achieved in reality, right? Kisima instrument, kisima object, there is no efficiency of 100%, right? The output is less than the input. Wastage on instance, right? Say you are pedaling a bicycle, right? The energy that you are inputting on the bicycle is less than what is required to go there, because you are doing work against friction, against air drag, right? 100% efficiency achieve that is not achievable, right? Okay, now efficiency is given as 40%. This is 40 now, and output is here 97.6 over. We need input, right? P dash into 100. I have to simplify this. 0 to 0 cancels. 2 times 2 and 5. P dash simplify. 96. 696 into 3.73. If there are differences, let me know. Is it 2596.08? 2596.08. मैंने मेगा बान वैल्यू 2596.08. 596.08. $6,490.2. 6,490. 6,490.2 watts. 6. You also simplify these values and check it out whether these values are correct. 6A. 6. The boat rides safely by immersing all 6 tubes hang around the boat up to the water level when the boat comes to an area with air bubbles. Right? When air bubbles are mixed to water, what happens to the density? Question what happens to the density if air bubbles are mixed? Increasing or decreasing? If air bubbles are mixed, is it increasing or decreasing? About effective density? Question? No. Effective density? No. If air bubbles are mixed with water or any other liquid, density decreases. That resultant density is called the effective density of the liquid. Right? So that's why one practical scenario of this, practical example of this is, say this is a waterfall. This is a waterfall. This is a waterfall. Right? Now this is a river upstream, and here this is a waterfall, and this is the bottom of the waterfall. Right? This is the bottom of the waterfall. I have explained this example in the theory class, I guess. Right? Paper class again, question. Right. So at here, have you seen that air bubbles are there? Or white waters are there? Right? What's the color of water? Red, green. Colorless, no? Right? Water is colorless. Now, if you see white waters kine color dena? White water? Anyone who has done rafting? Rafting kalla dena? Nah. Rafting. Done it. Rafting? Done. Rafting have you seen rafting? Sport? Rafting rafting is also called white water rafting. White water rafting, right? The reason is when air bubbles are mixed with water, right, it is visible in the whitish color. සුදු පාටට වතුර පේනවා නම් ඒ තියෙන්නේ air bubbles ඇදිලා හින්දා. example එකක් waterfall එක bottom එක. Have you visited to any waterfall? දන්නවනේ. Then at the bottom, I mean close to the bottom, in this area around, we can see white waters with water bubbles actually. මේ තියෙන water bubbles තමයි. ඒක white වෙලා පේන්නේ. In water break වෙද්දි තමයි white විදියට පේන්නේ. When water breaks, right, that is visible in a whitish color for our eye when it breaks, right? So in any breaking points, water bubbles are mixed, right? දැකලා තියෙනවනේ මේ වැටෙන තැන සුදු පාට පේනවා. දියල්ලක් දැකලා නැත්නම් කමන්නේ නැහැ. කෝප් එකකින් තව කෝප් එකකට වතුර දාලා බලන්න වැටෙන තැන සුදු පාට වෙනවා. අන්න ඒක තමයි ඔය වෙන්නේ. Right? That is because air bubbles are mixed. Right? Air bubbles mix වෙනවා. තේ හදලා තියෙනවනේ. තේ වල පාට වෙන්නේ නැහැ. ඒකයි කේස් එක. වතුර දාලා බලන්න. Right? So when air bubbles are mixed, density of this area decreases. මේකට equation එකකුත් තියෙනවා. මේක න equation එක කොන්නේ I'm explaining something in the background. This is called effective density. Right? Rho effective. Effective density is 1 cubic meter minus volume of air bubbles. This is the only equation of effective density. 1 cubic meter minus volume of air bubbles in 1 cubic meter into actual density. Right? Make the equation. Right? Got the point? Now, say due to this, now this rho is decreased to 800 or something like that. Maybe decrease, may possible value. Abhi tanna throda 750, 800, 850 wage values wala make a drop වෙනවා. Right? Due to mixing air bubbles. Right? So therefore, this is the thing. Now what I needed to explain is, now maybe you are an expert swimmer, right? But yet, since the density of the water around this area is less, upthrust acts on the body is less. Right? Now, even if you are an expert swimmer, right, we have practice to not white waters but the swimming pools and everything, no? So their density of water is 1000, but in this kind of a place density of water is less than 1000. So therefore upthrust acts on the body is less than what is expected and what we have get used to. So therefore there's a risk of what risk of drowning. There's a risk of drowning, right? ඒකයි ගොඩක් වෙලාවට මේ මෙන්න මෙතන ඒ කියන්නේ මෙතන කියන්නේ මෙන්න මේ ඒරියා එකේ සාමාන්‍යයෙන් කට්ටිය මැරෙනවා වැඩි. කොච්චර හොඳ ස්විමර් කෙනෙක් වුණත් ඉතින් අප්‍රස්ට් එක සපෝට් කරන්නේ නැත්නම් it supports but the value is less, no? Usually mg equals u when we swim, right? mg equals u. හැබැයි මේ u එක දැන් මෙතන අඩු වෙනවා. So therefore there's a risk here if you are swimming around this. පොඩි රිස්ක් එකක් තියෙනවා. ඒක සාමාන්‍යයෙන් හොඳ ස්විමර් කෙනෙක් නම් ඒක තේරෙනවත් එක්ක ඒ කියන්නේ අප්‍රස්ට් එක අඩුයි කියන එකත් අපිට ෆීල් වෙනවා. right? ස්විම් කරන්න පුළුවන් නම් කරලා බලන්න, බැරි නම් කරලා බලන්න යන්න බා කොහොමවත් මැරේ. අර පුළුවන් නම් try කරලා බලන්න. මේ ඒ කියන්නේ වැඩේ දැනගෙන. ඕක තමයි කේස් එක. අර සමහර කට්ටිය කියන්නේ දියඇලි පාමුල බිලි ගන්නවා කියලා. බිලි ගන්නවා කියන්නේ ඉතින් යකෙක් ඇවිල්ලා අරගෙන යන්නේ නැහැ නේ. මේක තමයි වෙන්නේ. This is the science behind it. This is the physics behind it. ඔය ආච්චිලගෙන් සීයලගෙන් එහෙම අර බලන්න ඒගොල්ලෝ කියනවා දියඇල්ල මුලට යන්න එපා බිලි ගන්නවා කියලා. ඉතින් මේකයි ඒ හේතුව. අර දැන් ගල් එහෙම තිබිලා හිර වුණොත් ඒක it's a different story. right? ඒවා මොකුත් නැතුව මෙහෙම තිබ්බොත් ඇත්තටම මේ රිස්ක් එක තියෙනවා. අපි කොච්චර හොඳ ස්විමර් කෙනෙක් වුණත් වැඩක් නැහැ. ඉතින් ෆිසික්ස් පාර්ට් එක සපෝට් කරන්නේ නැත්නම් අපි කොච්චර හොඳට බිනවත් වැඩක් නැහැ. ඒක මේ ඩ්‍රෝන් වෙනවා. එහෙම තමයි හැටි. right? ඒතර මේ ඉෆෙක්ටිව් ඩෙන්සිටි එකේ තියෙන ඩිස්ඇඩ්වාන්ටේජ් එක ඒක. right? ඒතර මේක දැනගෙන ඉන්න. white waters තියෙන තැන් වල රිස්ක් එක වැඩි. that is called white waters. white means air bubbles are mixed. right? swim කරන්න පුළුවන් නම් ඒ රිස්ක් එක දැනගෙන ඕනනම් බලන්න ඒක බලන්න ඕනේ නැහැ. එහෙම එකක් දැනගෙන ඉන්නකො ඊට පස්සේ මාක් කරනොත් right? So that's it. that is called effective density. ඒක තමයි ඉතින් මේකේ තියෙන physics part එක. If the density of the liquid is higher, it is much easier to swim, much easier to float and swim, right? අර අනිත් oceans වල එහෙම නිකන් ඕනනම් අර වාඩිලා ඉන්න පුළුවන් oceans තියෙන දැකලා තියෙනවා. ඉතින් ඒ density එක වැඩි හින්දා අර තියෙන වාඩි වෙලා පොත් කියවන්න පුළුවන්. Dead sea එහෙම දන්නවනේ. ඉතින් එහෙම තමයි. density එක වැඩි නම් ඉතින් ඒ support එක වැඩි. ඉතින් ඒකේ swim කරන්න ඊට වඩා ගොඩක් ලේසි. ගිලෙන්නේ නැහැ ඉතින්. ඕනවත් ගිල්ලන්න බෑ. right? The effective density of water in that region is 800. Find the extra volume needed to be sunk. Right. Now, initially, we don't know which volume was immersed. So, therefore, I'm going to use this. Initially, we know mg equals v rho g. No? Say initial immersed volume means v1. Right? Initial mass of the boat is mg moment. Mg is actually u. මේ තියෙන u තමයි. That is 11600. v1 rho is 1000 into 100. Right? 0 to 0 to 0 to 0 cancels. Then v1 equals 1.16 cubic meters. Right? This is the volume that is immersed in the water of 1000 kgm minus 3. Right? Now, if this enters an area with density 800, what is happening with the upthrust? Increasing or decreasing? What about upthrust? What about upthrust acts on the boat now? If it enters an area with 800, what about the upthrust acts on the boat now? Huh? Decreasing. What's happening? Huh? Increasing? No. It is neither decreasing nor increasing. It is constant. If mass remains constant, upthrust is constant because u equals mg. No? U equals mg. This is floating. So therefore, even if it enters a lower density, then to counterbalance the upthrust, a higher volume is immersed now. Upthrust remains same. Right? ගොඩක් කට්ටියට පැටලෙන දනවා. density එක අඩු වෙච්ච ගමන් හිතනවා upthrust එක අඩු වෙනවා කියලා. No. Upthrust changes if and only if weight changes. Upthrust changes if and only if the weight changes. Weight is same, upthrust remains same. Upthrust remains same. But the density changes. See, for the second scenario, U equals V2 rho G again. Upthrust remains same because that's the same weight, right? V2, but 800 G, right? 0 to 0 to 0 to 0 cancels. V2. Mati model. Simple kara. 1.45. 1.45. Yeah. I got it. 1.45 cubic meters. So for sure, this volume should be greater than this one because when density decreases, to counterbalance the upthrust, to keep the upthrust at a constant value, from the other side, volume increases, right? Then again, it is balanced. Okay, now find the extra volume needed to be sunk. So therefore, extra volume equals, therefore, extra volume is delta V, 1.45 minus 1.16, 0.29 cubic meters, right? B. If tubes give 60% of the extra volume, find the volume of a tube. Okay. How many tubes are here in the box? That was given. How many tubes? 6 tubes. Then all 6 tubes give 60% of this extra volume, right? So therefore, 60% of this extra volume is given by 60%. 60% of the extra volume is given by all 6 tubes, right? If we need 1 tube over 6, right? Simplify this. 0 to 0 cancels, 6 to 6 cancels, 0.029 cubic meters. Volume of a tube, 0.029 cubic meters. That's the volume of the tube. Right? For all 6 tubes, that is 60%. For all 6, then 1 tube is divided again by 6. It is given as to cancel. Right? Listen. Now, as I told you at the beginning, the paper that we are going to discuss next week is a paper that you are going to write during this week, during the week, before Friday, right? So therefore, as I explained at the beginning, if you are writing physically, you can do it here at Leesa from Monday to Thursday, and at Machma on Mondays and Tuesdays, right? And for online students also, your link will be available, your submission link will be available from Monday to Thursday, right? So make sure that you are trying the paper, and if you are doing it physically, make sure that you are handing it over to the office, right? දැන් මේක ලියලා ගෙදර යන්න එපා මොකද ඊට පස්සේ බලන්න බෑ. ඒ වගේ ඩයල් ඉන්නේ. ඊට පස්සේ බෑග් එකෙන් දාගෙන යනවා පුළුවන් නම් යාළුවන්ගේ ටිකත් එකතු කරලා යනවා. ඒක තමයි ඉන්නේ. Right? So make sure that you are handing it to the office and then go back. Right? And if you are writing online, make sure that you are submitting it there and make the submission, right? So by Friday, I'll be collecting all papers, and my plan is to give the graded paper on the next Monday, right? So that will be the plan for this paper class this week onwards, right? Right. So therefore, now you are going to get the graded papers, which means you are going to get an idea about the exact level you are in, right? Now you have practiced like 4 or 5 papers with me here in the class, right? Now all the experience is there, right? Papers 5ක් ලිව්වා කියන්නේ නිකන් MCQs ගන්න multiply කරලා බලන්නකො. MCQs 50 ගන්න ලිව්වොත් 250ක් ලියලා තියෙනවා. 250 MCQs, right? 50 ගන්න ලිව්වා. ඒ වගේ තමයි. So having and understanding about your current level, then we have to get the corrective actions. You have to do the corrective actions. You have to follow the corrective actions to increase your level, right? So increasing the level is, increasing your mark is not something that you can do overnight, right? It takes time. Then, as an example, let's say now from the last MCQ paper, right? Out of 50, you have 30 marks out of 50. 30 are correct, right? So in the next one, target 35. In the next one, target 35. Just 5 more questions. When you target 35, you will end up most probably somewhere in between 30 and 35. Say you end up having 33, then next time target 38, right? And then you will end up somewhere, say 36. So likewise, after 3-4 months of time, you will see how you have improved, right? And as the next step, I'm planning to record all your marks on the website itself, right? And for you also, what you can do from your side is, it's better to record your marks for the papers in a table or somewhere. Paper numbers, with the paper number, you can record your marks for paper 1, paper 2, and total, something like that. Then, say 3 months down the line, if you check your trend line, if that trend is not an increasing one, right, which means you haven't taken your corrective actions. Indication, right? So therefore, you have to have an indication about your level. You have to have a reflection about your level. So therefore, it's better to record all your marks. This is not only for physics. If you are writing other papers in other subjects also, that is a good practice that you can do. Increasing trend right? So first thing is that self-awareness. When outside right? So first thing is knowing about yourself, knowing who you are, knowing at which level you are, right? Okay, so that's the thing. I think it's clear because I explained in the beginning as well. So I hope it's clear. If you have any questions that you didn't ask yet, you can ask tonight and get it clarified. I mean, about paper writing, if you have any questions, ask it and get it clarified. All right then. Any other questions? All good? All clear? Right. Online students, any questions? Is it all clear? All good. Now again, monsoon season is starting, right? It is actually already started. So therefore, be safe, especially the ones who live around the mountainous areas, right? Hillsides, mountainous areas. That risk of landslides is still there. That is there, right? So therefore, be safe, right? So I personally know there are students from Kandy, Kampola, Matale, right? They were very kind of prominent sites, prominent areas with severe landslides. So be careful and always be vigilant. Be vigilant and be careful, right? Okay, so stay safe. And if there's no any other questions, we'll wind up. Go safe and stay safe. Study hard, right? See you in the next class. Good night and goodbye.